Meet. We can't see you.
All right, we are live. Welcome to the SignWriting Symposium 2024. This is our fourth day. We are going to be covering software today. We have three presentations. The first one's going to be in English. The second one is going to be in English and Libris. And the last one is going to be in English by me. So it's going to be a very interesting day. The first presentation, let me just share the screen here for a second. The first presentation is about real-time multilingual sign language processing by Amit. Oh, can you say the last name, Val?
Hey guys.
I think it's Marios. Hi. I'm sorry. Sorry if I'm not saying.
Please turn on your
Let
phone,
me.
introduce yourself.
Yeah.
1 second. Let's see if the video works. Can you see me?
Not
Can't
yet.
you yet, so we need to see your video. It has to be on, right?
Yeah, it is on. 1 second. Seems like the wrong camera. Ah, yes. No, but if you give me a second, I will say hello from my phone. I will join. There
Sounds
we go.
good.
We have another person from a phone. Ah, that's cool.
Yeah.
Amit Moros. You'll have to say your name right.
Yeah.
I can't do it all at the same
Yeah.
time.
So
Okay.
it's pronounced Mor Yosef.
Oh, Morosef. Ah.
It's like Mor and Yosef just together. Mor
Oh,
Yosef. Mor Yosef.
now I
Yeah.
understand the name. That
As
really.
easy as that.
Thank you.
Let me try to mount you guys. Okay, cool. Yes. Hey everybody. Sorry, I cannot sign. Two broken hands.
Oh,
Life.
broke his hands. That's life. Yes, I guess.
Yeah.
Well, I'm happy with it.
Absolutely.
Okay, let's do it. Okay.
Yeah.
Well,
Yeah.
Amit,
So I'm really. Yep. Go ahead.
I'll just ask you, introduce yourself, tell us a little bit about yourself, and then we'll watch your video.
Perfect. Yeah. Hi, everybody. Amit. Also introducing myself in the video, but right now I'm doing a postdoc at the University of Zurich. I was introduced to SignWriting maybe at the end of 2020 and started working with it for real in the middle of 2021. I love the system and Valerie and Steve, of course. Let's see that. Okay. And as well as I've been using your stuff all this time, Steve, to develop my systems. I watched the last 3 days of live streams. Really interesting research happening in the sign writing sphere, and yeah, happy to open the software day, I guess.
It's nothing to open today. Well, that's nice. Yeah, we've been looking forward to your presentation.
Great. Yeah, I think we can just play it.
All right. Yeah, I've been watching your stuff, Amit, and talking with you, and I'm just really impressed. I'm really excited to watch your presentation. So let's get started. Oh, wait 1 second. Yes, I have the sound on. Good.
Hi, everybody. I'm excited today to give a talk about my PhD thesis, Real-Time Multilingual Sign Language Processing, here at the SignWriting Symposium. My name is Amit Moryusef. I'm currently affiliated with Bar Ilan University, where I'm graduating from as a PhD, as well as associated with the University of Zurich as a postdoc in the project called Sigma. Industry-wise, I'm the owner and the only employee of a startup company called SignMT. We're looking for funding, and you might know us from our website, sign.mt. Cool, let's get started. Sign languages, primary means of communications for many deaf and hard of hearing individuals across the world. Sign languages are different, mostly geographically. I'm right now in Switzerland. I think you can even see a Swiss flag somewhere there. There is Swiss German Sign Language, and that has dialects as well, while an American might use American Sign Language. Here in Switzerland, we have many dialects for Swiss German, 6 of them in fact. One of them is actually Liechtenstein Swiss German Sign Language, but we also have Swiss Italian and Swiss French. When we look at research that is trying to do automatic sign language translation, we always see this kind of scenario. We want to take some kind of English text in this example and try to translate it to American Sign Language and see it in some sort of avatar or person that looks more real, or vice versa. We want to be able to take a video of a person signing and translate that into spoken language. And to add on that, I take a quote here from the Tiny Corp from George Hotz. He says that the hard part of programming is finding the right way to factorize the problem. The rest is fill in the blank. I couldn't agree more, and I wrote my entire thesis about factorizing the problem to use SignWriting. Let's look at some representations that exist for sign languages. So we start with videos usually. This is a sentence, what is your name? People use pose estimation. In this case, we're using MediaPipe Holistic to represent a skeleton of the signer. Or people can use SignWriting, a phonological representation that can write down the signs one at a time. We also have others, such as hypnosis here, for example, or we could also use semantic notations, semantic transcriptions, like glossing. In this case, we have the glossing, your name, what. All right, now my proposed pipeline for the sign to spoken translation. That is a pipeline where we take a video as input and we return audio as a spoken language as output. My proposed pipeline goes like this. I propose that we start by taking the video. We run pose estimation because it's cheap, because it kind of extracts a lot of the human body information from the video. We then perform segmentation. Segmentation allows us to know where is every sign and every sentence in the video. So here, for example, we can see that there are 3 signs. The first one here is in pink, the second one here is in green, and then the third one here is in blue. And the signs are your in American Sign Language, name, and what. Now that we have the segmentation, we would like to perform transcription. We use SignWriting, which is a system, as you all know, that allows to write phonological features of the signing in a lexical manner. For example, here we have the SignWriting for the sign who in American Sign Language, and so we have some annotations for the face, the eyebrows, the mouth, and the movement of the face forward, as well as all of the characteristics of the hand and the hand's movement. We then take the segmented videos. So we have a video of someone just doing this, and we would like to transcribe them using SignWriting. We transcribe them automatically to the sign here, or the sign here, or the sign here. And that we have a link here. You can always follow, by the way, there are links to all of the works. Yeah, and then we have all of the sentence transcribed. The next step is to perform machine translation. Now that we only dealt with sign language, we did not do any English part yet, we take this problem to machine translation. We've worked since 2022, I believe, on automatic machine translation systems that can take SignWriting text as input. For example, the above here, we have sentence in SignWriting, and that spits out what is your name in English. Finally, if we want to make the text into audio, we consider that problem trivial, and we leave that to the browsers or devices to deal with. So in theory, what I'm suggesting is that we have the video as input, then we take it into pose estimation, we segment each sign, we transcribe the signs, and then we perform translation. In reality, this is also what we have. So here we take it from bottom to top. So we have a video here, the same video as before. We then have here a transcription, or first of all, a segmentation, a segment of the SignWriting, 3 SignWriting. We then have transcription, 1, 2, 3 signs. This is written in a linear form and not in the form, the 2D form that we're used to, but it's the same in practice. And finally, we take all of these signs. We also know what is the sentence boundary, and we automatically translate to English. In this specific example, the only thing that is not real, that is not automatic, is the automatic transcription. So we know where the signs are, but here I manually transcribed them. Let's move on to the other pipeline. So we had this sign to spoken pipeline. Now let's talk about the spoken to sign translation pipeline, and this is a little simplified for this presentation. So we start with audio to text, speech recognition. Let's call that a solved problem and move on. Then we perform language identification, because it's very important to us to be able to translate. For example, here there is a sentence in German, but we're trying to translate from English, and our systems are not really good for that kind of scenario. So we do language identification. Then to also work directly on the input might include errors. For example, here is input in English: a important part of my life have been a people that stood by me. And we know that if the input to our machine translation is wrong or is not exactly right, the output will also be wrong. So we also perform a language correction using a large language model that basically fixes all of the errors above. Now that we have spoken language text, we can perform, and we also, of course, can recommend these changes when a user actually uses the system. Now that we have the text and it's correct and normalized, we can take the text, what is your name, and translate that into American Sign Language using SignWriting. This is a system that currently is in production and translates between the two. Now, given SignWriting, we would like to animate that. So here is an example of just the translation system. So, hello, my name is John, and we see that in SignWriting we have a hello sign here, and then I name John in fingerspelling. If now we wanted to animate that, then we also worked on something called motion diffusion. This work specifically takes hamnosis and animates that into a skeleton. And the animation was quite of good quality. We're very pleased with it. We would like to move on and also use it with SignWriting in the future. We get the skeleton, and we would like to animate that into a person. Now, of course, this person does not look very realistic, but you can see that it's mimicking the movement of the skeleton. We have works that give better reconstruction, and we'll show them shortly. Here, for example, we have the post-to-video library, where this is a video like you saw before, and our current system, or even before, a better system generates this. It still does not look quite right, but our current system generates this video, which is a lot more human. It might not still be fully correct or fully nice to view, and we hope that advancement in computer vision will also advance this field. Another aspect that people try is to take this pose and animate an avatar. I have a YouTube video here that you can watch where I try to do that. It does not succeed very well. I guess that I would like in the future to get back to that. We also perform baselining. So we also try to do this translation without SignWriting. I believe that using SignWriting is the correct way to do so. But if someone, for some reason, does not believe so, we also compare to a baseline. The baseline takes a sentence here in German, glossifies it using some rules and some lemmatization, then looks up the signs in a database somewhere, a lexicon, stitches them, and reanimates them. And this is how the baseline looks in reality when we have a sentence, kleine Kinder essen Pizza, little children eat pizza. Then we have little, then we have children, we have eat, and we have pizza. Now, this baseline system clearly is wrong. When I show this to hearing people, they're always, oh my God, it works, great. But when I show it to deaf people, they laugh. And why do they laugh? They laugh because this small children does not make any sense. This small would mean thin to children. Like it might be a small, but it might have a different sense in this exact sentence. So this system is not very context aware. And so I believe that using SignWriting, we're also able to perform context aware translations. We have it all in a website called sign.mt. MT stands for machine translation, where you can demo our work, you can try to perform translations, as well as we see that there are thousands of people every month trying to access the website and translate, and the stars that for our repository on GitHub increase substantially month by month. We encourage you to also star us on GitHub, as well as just try our system and give us feedback. The real pipelines that are implemented are not as simplistic as I showed before. We have more steps, and actually I believe that we even added more steps since this slide was created. You can see the status for each one of these steps and how they are implemented on the website. So for example, here we have in red, SignWriting to pose sequence. That is red, that means that the website does not have that, and at the moment it takes alternative routes for getting to the pose sequence. We have a bonus pipeline that is of some interest to me. Someone was wondering about sign language anonymization. Given that there is a video, how can we anonymize the person? And I was thinking about it, and I was thinking, oh, SignWriting would be the perfect candidate to do so. We could take the video, we can take half of our original pipeline from video to text. In research.signmt about all of this research area, we have built a pose library to work directly with the skeletal poses in Python and JavaScript. We have a dataset repository that allows to load and work with large datasets for researchers. We have the SignWriting Python utilities. Thanks a lot to Steve. There are many utilities written in JavaScript, but sometimes, or for my specific research, the clusters we run Python on them. And so I also built some of these utilities in Python, including tokenization that does not exist in the JavaScript implementation, but as well as the visualizer and other stuff. Other projects that we worked on, just to interest you, might be the SignWriting illustration. This is a tool that takes SignWriting as an image here and can illustrate from it. So it takes SignWriting and generates a human illustration that sometimes people prefer, or I guess people who are not familiar 100% with SignWriting would prefer to view. This project is undergoing, and we hope to have good results soon. We also have the SignWriting description project, which instead of trying to illustrate, we try to take SignWriting and describe it in spoken language. For example, the description for this hello sign would be with your dominant hand open, touch your forehead and move your hand away, palm facing out. So it's not exactly right because we have dominant hand open and not like this. This is one open, but the fingers are closed. So it would be, this is what the description is saying. We have a way to compress sign language videos as well. This is called a SignVQ. It's a vector quantizer. It takes sign language poses and quantizes them or compresses them to a very, very small representation that can then be used in language models. We have worked on cleaning the entire sign bank dataset, so all of the sign puddles. When you train a machine translation system on the original sign puddles, we get bad translation scores. For example, here when we see sockeye original, we have 0.2 and 8.4. And when cleaning the data using a language model, we have 22 and 28, which is a huge increase in performance. We have the SignWriting evaluation that is given to SignWriting signs. How far are they from one another? And we have 4 methods to evaluate it, either by looking at the pictures like clip score, like doing symbols distance, that is looking at the actual symbols and figuring out how far they are in Unicode, tokenized blue and character F, which actually work on the character level of the FSW, for example. We have an alignment tool that allows people to upload videos, then it automatically segments the video into sentences that they can translate or realign if they already have captions, as well as automatically transcribe the SignWriting and translate it from the SignWriting to spoken language text. And I guess that's all for today. Thank you very, very much for watching my talk in the SignWriting Symposium. I hope you're having a great day. If I manage to stop this.
Okay. What a wonderful presentation, Amit. Thank you.
Thank you very much.
You have so many tools that people can use now, right? You've added things that we can do now, right? We can go up on your site, which is .mt, is that right? For
Yeah, sign.mt. Yeah.
Oh, sign.
So
Go ahead.
sign.mt. Yeah, exactly. No, it's mostly built on stuff that Steve worked on in the past, whether it's just the Unicode system for SignWriting or all of the other tools to work with the different formats. And then, yeah, we built many tools on top of it with AI and machine learning.
And with AI, that's interesting. Yeah.
Yeah.
Is AI really helping with your development?
Absolutely. Like all that I do is AI, as in I am working to translate sign languages to spoken languages using AI and using SignWriting. So we have AI models that take spoken language and give out SignWriting, as well as models that take SignWriting and give out spoken language, or models that take SignWriting and give out video, or video to SignWriting. I'm really hoping to, in the next year, possibly, to give out back to the community a model that allows you to take any video and it would automatically transcribe it. So you would upload a video and you would get the SignWriting back. That would be really, really cool. And that would allow us to perform automatic translation.
That is wonderful. My God, there's so many people talk with me and they say, well, when you can really go to Google and really type in something in SignWriting and search all of the World Wide Web in that language, that'd be really cool, they tell me. Do you think that day will happen?
I think that they will definitely be able to translate stuff. I think that people will be able to go to Google, and the same as they can activate the microphone and speak, they will be able to sign. The search itself will probably not happen directly in sign language. It will take their sign, it will translate it to a spoken language, and then actually search like this. But yeah, it's a translation is the bigger use case that I think Google will go for.
Yeah, I'm sure it will happen. You're doing that work right now. It's sort of progressing, right?
Yeah, of course, exactly.
Really, thank you for doing all this. It's like a dream come true, as they say.
Yeah, wonderful.
Yeah, and
thank you for the simultaneous interpretation today.
You know, I'm not a professional interpreter. I've been telling everyone.
Yeah.
I'm hoping we can later put up on the World Wide Web each presentation and maybe ask an interpreter to really come in and do a good job, and then we can connect the interpreting to that World Wide Web page. Because
yeah, that would be possible.
I mean, it's not right. I mean, I should not be using a language that I'm not, trained to be professional, but I'm trying my best. So yeah. Thank you. And Steve, what would you like to say?
Oh, I just am really amazed by all the projects that you have. You even have more projects since you made that presentation with the mouth movement.
Yeah.
Yeah, exactly. We took data sets for fingerspelling, and we automatically transcribed them in SignWriting because we have the fingerspelling transcribed in English, as well as now using mouthing data sets to transcribe them with the speech writing system, or the speech writing and sign writing system. And so it's been really good. Projects have been piling up and piling up. I've been decommissioned for about 2.5 weeks, but hopefully I'll start working again very, very soon.
That's very interesting. Is that why you were interested in getting the mouth movements understood? Is because you were using translation? Oh,
Exactly. I think that when training a model to look at a video and transcribe it in sign writing, we need lots of data of videos and sign writing. Now, it's very difficult to get such data. In fact, I have only 10,000 signs transcribed from a video. And so one way to enrich the system's data is to give it data such as mouthing, which we can get millions and millions of videos online of just mouthing to tell the system, this is how mouthing looks like. And then finger spelling. This is how finger spelling looks like. And that helps the system to learn other things, because it needs to really focus on the face. It really needs to focus on the hand shape. And then, from there, it helps transcribe.
that's really interesting. Wow. You never know what something is going to be used for, right? Because the mouth writing was very nice for education, to teach people how to say something, right? But now you're using it for translation for computers, right? I mean, that's
Exactly.
interesting. Wow. Okay. Well, thank you. That was a beautiful video also. And you did a very clear job. So, and you continue to work in Zurich? Zurich
Yes, I'm still at the University of Zurich.
is a university. That's wonderful. Well, I know some of the people, maybe some of the older people. So say hi to those. Okay.
Yeah, I
will.
got one other thing though. I'm just really happy. It's amazing what you've done with the work that I put out there, because that's really my hope right now, that I'm putting out these tools for other people to work on and build with. And it's just really great to see it moving forward. And I love, love, love the idea of using sign writing as the intermediary form when you're translating, because like you were saying, translating from gloss, it's not ideal. It doesn't work right. But going from one written language to another written language, the translation possibilities are really, really promising.
Yeah, exactly. I'm really stoked about what the future will bring. All thanks to 50 years of sign writing.
Yeah.
Yes. 50 years. How'd that happen?
Insane. All right. Thank you very much for having me. I will continue watching from the live stream.
Thank you. Take care of me.
So, thank you.
Wow. So exciting.
Yes, beautiful presentation and also surprisingly good work and all of these figures.
All right. Give me 1 second here. All right, our next presentation, an attempt at a Google Docs for sign writing, Letra Sinal. All right, by Wallison Ruan Alexandriano. Oh, I'm so sorry about pronouncing names. It is going to be in English and Libris.
Global SignWriting. What?
All right.
Well, son, you want to come into the Zoom and talk with us? later, you're welcome, you know.
All right, here we go.
Okay, it's gonna start.
Hello everyone, I'm Watson Huang, or just Huang, and this is my sign name. You do a debut, and then you place it on the side of your mouth and go upwards and downwards, touching your face. Right, somewhere on your screen, you will see João Guilherme. He will be translating this talk from English into Libras, the Brazilian Sign Language. And thank you all for coming and watching this presentation. So, what will be the topics I will cover in this presentation? I have 5 topics. First of all, I will show you what is the current version of Literacy Now, what you can do with it, where you can go to access it. Second, I will talk a bit about the reasoning behind the creation of Literacy Now, the challenges I had and the ones I have today. First, the future. The future I have in mind for Literacy Now. What do I want to do with it? 5, I will do a bit of a dev talk. And that's it. So let's start. First thing I will do is to walk you through Literacy Now. I'm going to share my screen. Right. Right now you will see localhost, but currently Literacy Now is accessible by going to literacynow.com. I will not use the online version because it is in Portuguese, not in Portuguese per se, but in my computer it will be in Portuguese. Literacy Now today is smart enough to recognize your local language and translate the website to that language. As of now, I have not implemented a button where you can click on it and change the language. It all works automatically. And if Literacy Now doesn't know how to translate everything to your language, it will default to English. Okay, let me go back to the English version. Right, this is the home page, the current home page. As you can see, it has a warning up here. It is saying that your data will not be saved online. Currently, in Literacy Now, it's only front end. It only has the interface for the user to interact with it. It is not sending up any data to the cloud. So anything you do will be saved on your computer, more specifically on your browser local storage. So for example, Chrome has profiles. So you can see I have a bunch of them here. And if I change my profile, my data will also change. So I will not be able to reach, for example, the data from profile 1 into profile 2. This is just a temporary implementation. In the future, Literacy Now will be able to send data up to the cloud, and then you will have a user for you to access your data anywhere you want from any device you want, right? So, well, I have no document here, so I'm gonna create one by clicking on this button down here. Now I have a page, and well, what do I wanna do? I have a text I want to write here. So let's start. Currently, Literacy Now have the option of pulling sign from sign button. So as you can see, I can either click here or use a keyboard shortcut. This shortcut here is specific to macOS system, but if you are using a Windows, it will show you another set of shortcut. So for me, it is Control, Command, and P. For you, if you are using a Windows, it will be Command, Alt, P. So let's do it. Let's use this keyboard shortcut and see what happens. I'm gonna click on the page again, hit Control, Command, P. Well, so what I want to write? Well, I want to write the Libras version of a text. So let's type it here. First of all, I want to say Libras. Let's try to find the best sign for it. You are seeing the sign changing. I am doing it by clicking on the arrow down key. You can also go up. So let's try to find the best sign for Libras. I like this. Libras. And I want to write hello in Portuguese. Also, my sign. I want to introduce myself. I like this one. And my sign is Madison. I have previously registered my sign in Sign Puzzle. So if you haven't, I recommend you to go there and register your sign so that you will be able to pull it from there and add it to your text. Madison and let's find the best sign for I like this. I am a developer. Right now, nice to meet you. Oh, you. I like this one. Right. Well, I want to add some punctuations here. So for example, here I want to add a semicolon. I'm gonna add a space here. Now I want to add an exclamation mark. The things I'm doing it using the keyboard. So if I press space, I'm gonna have a space up there. If I press dot or exclamation mark or quotes or parentheses, they all will show up on the page right behind the current, or in this case, right on top of the current. Okay, I left it this way because, well, every sign language will be using the same symbol actually for exclamation marks, dot, parentheses, and so on. It is part of the sign writing shutdown system. Okay, this is my sign, space here, one is some. I'm gonna add a comma here. I am a developer. I'm gonna add a full stop here. Now, nice to meet you in the exclamation mark. I like it. Now, I want to do this very same text in ASL. So let's create another page. So I'm gonna go in insert, and I can see I also have a shortcut to add a new page. I'm gonna use it. So it is for me, a Mac user, a command return. So I'm gonna click on the page, and I'm gonna hit command return. I have a new page here. Let's write it in ASL. So I'm going to change the dictionary to USA, United States, dictionary US, apply. So ASL, hello. I like this one. Hello, my. Yeah, I like this one. My sign, name. The name is Wallison. I let me change this to exact word. So I work as a developer. Right, let's try to look for any part of the world. The success, well, since the developer sign, I believe is the same, both in Libras and ASL. I'm gonna use the Libras version. Now, in detail, LitraSynal is constantly learning about you, and it will try to save as much results as it can. So every sign you guys are seeing up here, they were pulled from SignPuzzle. I am using the SignPuzzle 3 API which is a way of my application connect the Sign bundle tree and pull in some data from it, right? But do I want to do that every time I search for the same sign? No, I don't. That's why Literacy Now, every time you press enter or just click on a sign to add it to the page, Literacy Now will store it in your browser, in your local storage. So my sign, it is not being pulled from Sign Bundle anymore. Since I have already used it, it is being pulled from my computer. So it is going to save resources, and that means it will be faster because you will not have to wait for it to go to Sign Bundle and then go back. It will instead go into your own computer and pull the sign from there. Nice, isn't it? Okay, so where was I? ASL. Hello, my site name is Wallison. I work as a developer, but I'm gonna use the Libre sign. So then go video. That's it. Now, nice. I like this one. Nice to meet you. You, this one. Awesome. So let's format this text. ASL, space, hello, exclamation mark. My sign name is Wallison, and I work as a developer. Okay, go back. Developer, nice to meet you. That's it. Now, what if I wanted to do this, but from left to right? Well, it is as easy as going into format in the top bar, selecting left to right. Since I was with this page active, the text changed only here. So yes, you can have both writing directions in the same document. I'm gonna do the same up here. So I click on the page, you can see the color is active here. Now I'm gonna left to right. That's it. So what about the space? What if I want to see the space or the tabs? Let's see, let me add some tabs here. Yeah. Now let's visualize them. I'm gonna go into view and click show non-printable characters. Well, you can see I have a bunch of spaces here and also some tabs. So I'm gonna delete the tabs. Let me see down there. Okay, I also have a bunch of spaces here. Right. Let me go back to my preferred direction of writing, top to bottom, and down here, top to bottom. Right. I don't want to see the spaces anymore. All right. Now, what if I want to go to the next column? There are two ways of doing it. The first one is to keep adding signs until you get to the next column. The second one is to use the spaces to go to the next column. Let me do it here. All right. And the next column, as you can see. Currently, I have not been able to implement what I call break flow. Break flow is what we do when we are writing some text. Let me see if I can find a way to show you an example. Okay, let me go to Google Docs. Create a new doc. So what I call break flow is the component that does this. Let's say I have a text here and I want to go to the next line. I can hit return for Mac or enter for Windows. And voila, I am in the second line. Currently, the functionality to do this in Literacy Now is under development. So it is not going to be shown in this presentation, but as soon as I implement it, I'm going to share with you through the SignWriting mail list. So if you have not subscribed to it yet, please do it. Or I will be sharing with you through an Instagram profile I will create for later scenario yet. And when you guys see this video, it may be already created, and I will link it in the description below the video or in the comments. So stay tuned. Right. The brick flow, it will work for both top to bottom and left to right. And right now, if you try to use it by hitting Mac, return, or for Windows, enter, you will see this. Functionality in development. The line column break character has not yet been implemented. This is my way to let you, possible users, to know the functionality you are trying to use is under development so that you will be up to date about with how literacy now is progressing. Right. Okay. So you can see up here, the document has no title, no personalized title. Let's change it. Let's see, SignWriting, Symposium, 2024. It's now an attempt at a Google Docs for SignWriting. Hit enter, saving. If I go back, I'm gonna see it here. I can also rename it from here. So let's remove the second part. Leave just this. Rename. The name was changed. As you can see, every change I do in the pages, they are saved automatically to local storage. But if you are not sure it was actually saved to local storage, you can press Ctrl Command S or Ctrl Alt S. It will save your changes. This may change when you guys see this video. So yeah, stay tuned for any video or any email in the SignWriting mail list. I will be keeping you all up to date with the web application with this text editor. Right? So this is it for the demonstration. I'm gonna stop sharing my screen. Now, the reasoning. Well, I guess as any user of SignWriting Symposium, I am an avid user of Symposium too. It is good to register signs and to build them, to see what authors have written down, etc. But currently, it doesn't have a way for you to write a full document, to write just as you would do in the Google Docs. Well, we also have the Legs, a German web application that is also a text editor for SignWriting, but the problem is the Legs is written from left to right, and we Brazilians, we use this from top to bottom, so the leg doesn't actually solve our problems, but it does indeed have a great interface, and literacy now will be copying some of them. We'll be modeling some of its interfaces, user experiences in the likes, right? So I tried to do something before. For example, let me show you some of the applications I tried before. Just to give you a bit of a context, I became a software developer 2 years ago, almost, and I wasn't really good at it. So I had to practice a lot, and SignWriting was a motivation for me because I really wanted to give back to the community by building something to make their lives better. So first thing I did was, how hard this to build an application using SignWriting? First thing I did was this. Let me share my screen again. This is the very first version of Literacy Now. Very simple. Let me hit play. Let me skip a bit. Right? As you just saw, it was a pretty simple version. You could use both Latin alphabet and SignWriting side by side. Yep, it was a really simple version, and it was what gave me the idea of building something way more complex as literacy now is today. And also, I tried one more thing. Let me share my screen again. I tried a Google Calendar. As you may have inferred, I'm a really big fan of Google, so that's why I'm always trying to build something that really looks like what I feel as their applications. So this is a Google Calendar. It is in Portuguese. I can change it to Libras. I can create events. So let's try to create one. Hmm, actually, let me go back to Portuguese. Wait, one, something. Let me get some FSW. Yeah, like this. We're safe. Back then, I wasn't aware of how to use reactivity systems, the ones you use to refresh the page upon any changes. So that's why I refreshed the page. You can see now I have something event happening today, and I can change it to Libras. These are the signs I pasted there as a formal SignWriting or FSW. Right, this was my second application using SignWriting. Right. So moving on, I also talked about creating a Google Docs extension to use SignWriting within Google Docs itself, but I wasn't able because nowadays SignWriting needs SVG to be on the web, and Google Docs currently doesn't support SignWriting. That's why I moved on to create a full application mimicking Google Docs, enabling some of its features and, well, supporting SignWriting. Now, what about the challenge I had? The challenges were mainly related to UI user interface, what the user should see on the screen. Second one, user experience. Second writing is this year, 50-year-old, but it doesn't have that many applications, which means it doesn't have that many designs for us to look at, try to copy, or try to improve. I tried to look for some of the implementation applications usage of SignWriting on the web. I could find SignPuzzle, the links, the Wikipedia for ASL and SignWriting itself. I found some other more applications throughout the web, but most of them were simple in terms of designs. They were mainly focused on the spoken language alphabets and not on SignWriting itself. Right, so it is a bit hard to develop without having some models to, well, model from. And that's why I really want to thank the deaf community, the Brazilian deaf community, because they have been giving me a lot of feedbacks on what to do with literacy now. And my third challenge automatic pagination. It is not strictly related to SignWriting, but well, it is one of my challenges. The first one is break flow. The two last ones, they are not, again, related to SignWriting. They are related to my knowledge of how to build a web text editor, right? So they are not big challenges, and I have to credit them, not them, the ease of using SignWriting to Steve Levinsky. I'm sorry if I have pronounced your name incorrectly. So since the creation of Symposium, Steve has been doing a great job in providing information on how SignWriting is used on the web. And he, if I'm not wrong, in 2019, he built a library which for non-developers is a code you can get and use in your own application. He built that library and I am using it in literacy now. And if it were not for that library, I would take a lot more time to develop anything using SignWriting. And well, I would not be lost if I hadn't that library because Steve also made sure that we had some documentations about how to maybe convert FSW to SignWriting on the web. So many thanks to Steve. And now, what about the future of literacy now? Well, for the short term or the short future, for the month to come, I will be refactoring it. I will be fine tuning some of the features we already have. And I will be again collecting feedback from the Brazilian deaf communities. And if anyone outside of Brazil wants to give me some feedbacks, feel free to do so. You will be seeing my LinkedIn, my email, somewhere around here. And or just drop a comment below the video in the SignWriting Sultan YouTube profile channel. I'm sorry. I will read them all. Right after that, I will be working on making Literacy Now a product. That doesn't mean I'm gonna be charging for everything. No, I have the intention of making it freemium, which is a way of having both free and premium features in the same applications. So the basics to write a document, to write a document, to write the text, to have it saved on the cloud, etc. I will try to keep it free. And as for the other features, I will make it paid, make them paid. I don't have a list of what will be free and premium yet. Aside of that, I will be trying to implement some things. For example, I will try to implement tables for SignWriting. I try to implement lists, headings, subheadings, a lot of things we have in the Google Docs. I'm gonna try to get them and add them to Literacy Now for to use SignWriting as a complete system as it is. Yeah, also one of the features I want to share with you is, or two actually. First one, I will be copying the lags user experience of adding sign to the page. Let me share my screen again. The lags or the lags, I don't know how to pronounce this correctly. You can do it by opening the application, hitting any word like OI. Then you can click on Shift and the forward back bar. You're gonna have another box here and you can anything you want. For example, I don't know, voila. I'm writing in Portuguese because as you can see on my right side here, I'm pulling the sign from the Brazilian dictionary, right? But you can do it in any other language. The Lex has a nice selection here, right? I will copy this so that the user will not have will not be mandated to hit a shortcut to open this small dialog box here and to write their sign to the page. Second one is, wait, let me stop sharing my screen. Second one is the feature of being able to add a full text literacy now uh, at once, and it will be converted into signs. So if I had a text in Portuguese and I paste it in literacy now, it would be converted to signs. I will also implement that. The Lex has that user experience, and well, I really like it. So I'll be importing it to literacy now. And thanks to João Paulo for recommending that to me. Right. For non-developers, this is it for this presentation. Thank you for staying up to this point. And well, I hope you will like literacy now. Send me any feedbacks you have. Now, what's the dev talk? Into the small talk, I just wanted to share some challenges I had. But first of all, let me share with you the stack of literacy now. Literacy now is built upon the same stack as Sign Bundle 3. As you can see here, I got this diagram from HPish, a presentation Steve did back in 2016, the last symposium. You can scan this QR code here to get to that video, or just go to YouTube and search for this, right? Also, SignWriting is built using TypeScript, Vite, and Vue.js. Since I am using Vue.js, I'm also using Vuetify, which is a component library, and this is helping me to get some out-of-the-box component instead of being mandated to create them all from scratch. Also, I am using SignWriting web component. This is where Steve is shining. He built this library back in 2019, if I'm not wrong, and it has been stable since then. It is stable since then. You can see the library by scanning this QR code down here. You will be taken to Steve Levinsky GitHub profile, and in there you will see a lot, and I mean a lot of libraries of to help you use SignWriting on the web. It has a really good documentation. I really recommend you guys to go through all of it to clear your doubts. And if that is not enough to clear your doubts, you can go to Jitter or Gitter. I'm not sure how to pronounce this, SignWriting community. Steve had been volunteering his hours on the Saturdays. I forgot the time, but you can scan this QR code, go there and read the messages, leave some messages, share your doubts. You will be in contact not only with Steve, but with a lot of other developers working with SignWriting on the web, with artificial intelligence, and many other projects. I don't have any idea that is out there. It is surprising how many projects people are working on these days. Really awesome. The community is getting bigger by the day, and I hope with this video you will also join us. Right? This is the stack. Now, the other thing I wanted to share with you is how to use the SignWriting web components with Vue. I found some. I struggled a bit to connect them both. So let me share with you how I did it. Let me go to the code. This is my index.html. If you have not used a framework so far, this is not going to make much sense to you. So I'm going to try to explain a bit. Index.html is the file the framework will be using as a reference, because when you use a framework, it helps you to write robust applications, and in the end, it will take all those code, all the code you have just wrote, and then it will convert it to code you can actually put on the web, on your server to serve to the users. And this index.html will be part of the final bundle. By bundle, I mean a set of HTML, JavaScript, and CSS codes generated by the framework. Yep, so I had to add this tag here, script. I had to make it type module and write these lines here. I tried to use some of the links in the documentation which Steve produced to us, but I wasn't able to use them. After some debug, I landed on this link. It is working so far. What it is doing is it is pulling the library from a CDN network. CDN is stand for Content Distribution Network, if I'm not wrong. For you that is not experienced with CDN, let's imagine we have a lot of servers around the world. Let's think a user from Germany want to access literacy now. Currently, literacy now is based in Brazil, so it will take quite some time for literacy now code to reach Germany. How can I ease that? How can I make it faster? What if I had a set of servers along the way, or just in Germany, that I could store literacy now code in there, so that the next time the user would try to get literacy now content, they would not need to come to Brazil, get the code, and then go back. But instead, they could just reach a server closer to time to get the code from literacy now. Well, that's why CDN exists. That's how we can make it faster. And that's what I am using to get the SignWriting library. Right. This was not the only thing I had to do. Since I am using Vue with Vite, Vite is the bundler, is the one that will get all the code and compile it and make it shorter by minifying it, by converting TypeScript to JavaScript, etc. To it will make the final bundle. So for Vite, I had to add this. I had to ask Vue to ignore some custom elements that start with FSW. Now, let me use other words. So invite, I'm gonna say, hey, for Vue, do not try to parse the component that starts with FSW as Vue component. Instead, just ignore them, right? Why is that? If I don't do it, Vue will try to treat FSW component as its own, and it is not going to work because Vue doesn't have any context about how to parse, how to use those components, right? And this works just fine. Now, you have to be aware of some things. I just learned it recently. It was breaking my application halting out page, so I couldn't do anything once it happened. What was happening? Vue has a component called teleport. Teleport, as the name may suggest, it takes a component, an element from the DOM tree and move it as well into DOM tree. If it is a component handled by Vue, nothing will go wrong because Vue will know, oh, this is this component. I'm gonna move it to somewhere else, and I will still know what to do with it. But it is not the same thing with FSW components. So if I try to use FSW component within a teleport component, it will not work. Vue will try to make it work, but it will have no idea of what component that is and where to read what it should do with it. So just be aware of that. I am letting you know that because Beautify has some components that uses teleport under the hood. For example, component, it may not work, and overlay, the overlay actually also dialog. If you try to use FSW components within any of those, it will not work and you will halt your entire page, break the application completely. So yeah, take care. And that was it. I have shared with you my struggles with Vue and how to go past them. and also how you can get the components to use SignWriting on the web, where you can get it from, also how you can stay in touch with other SignWriting developers. That's it. If you had any doubts, if you should start or not an application using SignWriting, a web application specifically, fear not, you are not alone. You can reach out to me, to Steve, or go into the Jitter or Gitter. I forgot the word for, okay, hate social. I'm gonna leave it in the subtitles. Yeah, and talk to all of us. We will do our best to help you. And thank you for staying up to this point. And I want to thank some other people. First of them is my wife, because I have been developing my next literacy now, and she has been really patient and encouraged me a lot to go through with it. Also, I want to thank Valerie and Steve for building this amazing system and doing their best to provide everything we need, not only the system but the information to connect all of us through the symposium or the mail list or the Facebook group or everything they do. Thanks a lot. Also, I want to thank Carlos Christian. You may know the guy. He's always in the mail list because he's a avid content creator, especially related to SignWriting. He has a SignWriting course. If you are interested, just go to his YouTube channel. You will be seeing a QR code somewhere here on the screen. I also want to thank João Paulo. He's a Brazilian deaf author, so he has written his thesis using SignWriting. It's an amazing work. I'm gonna leave a QR somewhere on the page also for you to check it. It has a lot of different things I had never seen. For example, he made a table using SignWriting and many other design features that will be for sure working to implement in literacy now. And he's also encouraging me a lot. Lastly, but not least, João Guilherme, the interpreter you will see somewhere on the screen. He has been also helping me with the designs and giving me a lot of feedbacks on how to develop things. And yeah, thank you everyone else, especially the Brazilian deaf community. I am in 2 WhatsApp groups, and whenever I post anything about literacy now, asking for feedbacks, they promptly give me some. Also, they produce a lot of books. Last year, if I'm not wrong, they released, published actually 4 to 5 books, ranging from children to religious books. Pretty awesome. So keep it up, guys. And yeah, thank you all.
Thank you. Thank you.
Oh, thank you. That's awesome.
I'm so really impressed. I didn't know that it was such a developed program. So much information. It's really.
Yeah, and Wally-san also left a comment on the YouTube that he's integrated the sign maker into Letrasenal, so you can actually edit signs and add new signs directly writing them on the web. He hasn't released that feature yet, but he's got it working.
That's wonderful. The sign maker and also the sign puddle that he's been using both, right? And then he talked about sign puddle 3. I saw that. And that's a wonderful program also. So it's really impressive, so much. I didn't know that was happening. I guess you knew, didn't you, Steve? But
I'm surprised every day and amazed. It's really great the way that people are just creating more and more. And again, I'm so happy that I'm able to provide these tools and people are able to build on top of them, because that is exactly the idea. Nowadays, I can't focus my full time on SignWriting, developing applications, but if I can create the tools that other people can build on, it's exactly what I'm doing. So
So then the creative people who are the software developers can use your tools, right? And
Right.
then build more. It's sort of like they're building on your big shoulder. There's a phrase for that, right? But anyway, thank you for the presentation, Wally-san. I was so happy that you talked about the other programs, like the German program called DELEGS. That's wonderful. And I know that you talked about other programs too. So all of them should be included. And later I'll try to get some of the history. You know that there are other programs that were used and then stopped. And so there's so many people who have put in so much information that it just builds every year, right? We have more and more and more. So anyway, thank you for that very interesting presentation, I thought.
Mhm.
Oh, one last thing. I was just happy that you talked about the SignWriting email list. Wally-san, you're right. People can join and talk on a list of email. And so if you need that contact, I can give you that later. Okay, Steve.
All right, next up is me.
Next.
This is going to be the final presentation of the SignWriting Symposium this year.
The last presentation for the SignWriting 2024 Symposium. Thank you, Steve, for making this possible.
This is this has really been a great event. I really want to just thank all of the presenters that have already presented. Their work is very inspiring and gratifying to know that we're able to help them with what they want to do.
With your work. We're happy to help you all with your work. Okay, there we go.
All right, we have formal SignWriting, the basics, software, visuals, and searching. Well, first, I'm Steve Slavinsky. I'm a sign language user. I'm a friend of the deaf and a SignWriting evangelist. I'm the creator of SignPuddle, the Sutton SignWriting encoder of 2010, which is the International SignWriting Alphabet 2010. The encoder of the 2012, which is formal SignWriting in ASCII, and the encoder of 2017, which is SignWriting in Unicode SWU. I'm the system administrator of SignWriting.org, and I'm the author of the Sutton SignWriting packages. You can find more information about me at steveslavinsky.me. All right, we're talking about Sutton SignWriting. It is the universal and complete solution for written sign language. It has been applied by a wide and deep international community of sign languages. Sutton SignWriting is an international standard for writing sign languages by hand or with computers. From education to research, from entertainment to religion, SignWriting has proven useful because people are using it to write sign languages. Formal SignWriting, which I'm talking about today, is one particular computerized encoding for Sutton SignWriting. The design is based on character processing with regular expressions. With formal SignWriting, each sign is written as a two-part word of time and space. Whereas American Sign Language is a natural language, formal SignWriting is a formal language. A formal language uses words and punctuation to form text. Each word is expressed as a string of characters. Well-formed words are governed by the structural rules of the grammar. A formal language is useful in mathematics, computer science, and linguistics. Formal SignWriting has 4 design principles. First, where it's complete. Whereas Sutton SignWriting is a complex script with unique requirements and processing, Formal SignWriting supports all of the structures inherent to the script. Universal. Where Sutton SignWriting can be used to write any sign language, natural or constructed, formal SignWriting supports all sign languages without requiring the addition of new characters or updated fonts. Empowering. Sutton SignWriting is flexible enough to let each writer decide how they want to write their signs. Formal SignWriting enables the writers to decide for themselves the spelling of their respective signs. And possible. Sutton SignWriting is a practical script because it makes it possible to write sign languages. And formal SignWriting is a practical encoding because it works with existing font technologies and across operating systems. In this talk, I'm going to be covering 4 main topics. I'm going to be talking about the basics with the character set, the 2-part word, sorting, and punctuation. I'm going to be talking about the software available. We have the core, the font database, the font true type fonts, the SignWriting web components, and SignMaker. We'll be talking about the visuals. We have SVG with fonts, we have self-contained SVG, and we have the styling string. Also going to be talking about searching, query languages, regular expressions, and transformations. I hope to cover all of these topics in the basics, and it will tell you the different areas that are available, and you can find more resources to go in deeper in any of these topics that you find interesting. All right, we have 2 character sets. We have formal SignWriting in ASCII, FSW. It was released in January of 2012 and has been stable since it's been released. FSW only uses characters from the ASCII subset that you can see on the screen. SignWriting in Unicode, SWU, was first published in October of 2016 and officially submitted to the Unicode Technical Committee in July of 2017. SWU is not part of the Unicode standard. SWU is an experimental Unicode design that is supported by the Sutton SignWriting community. This alternative encoding overwrites the Sutton SignWriting block in Unicode and uses plain 4 for the SignWriting symbols. Let's take a look at what formal SignWriting and SignWriting in Unicode looks like. You can see we have the sign written right there. You can see the ASCII characters. They go out in this long string. For the SignWriting in Unicode, you see 2 different sections. The top with the U+ notation denotes each of the Unicode code points used. Below that, you can see the visualization of that string using the Sutton SignWriting 1D font. The basics of both character sets can be explained in this graph. We have the sequence marker that exists in both character sets. We have the sign box markers. We have the B for horizontal writing, and we have the L, M, and R for the left lane, middle lane, and right lane for vertical writing. Each of those has a SWU code point. We have numbers from 250 to 749. With our 2-dimensional writing, we are using Cartesian coordinates, which are made up of an X coordinate and a Y coordinate. And each number has an associated SWU character. We also have our symbols. In the FSW characters, you can see our symbol keys. Symbol keys always start with the letter S, and they go out for 5 characters. Each symbol of the International SignWriting Alphabet 2010 has a unique SWU code point. We look at those, the FSW and the SWU strings I showed before, we can see a little bit of a comparison. For the FSW string, we have the A, the sequence marker, which has 1 character, which has an associated glyph. We can see that we have the symbol keys in FSW. Each of those go to a specific code point, and you can see the glyph that is associated with each of those. We have the M for the middle lane sign box marker. We have the character and the glyph. And finally, the FSW string, you can see we have 525, which is a number. It goes to 1 specific SWU character, and it has an associated glyph. If you look at the glyph, you should be able to see that it has the number 525, but stacked vertically. This is to cut down on the amount of space that it takes up and make the string a little bit more compact. All right, let's talk about this 2-part word of time and space. Every sign written will have a spatial sign box, but some will also have a temporal prefix that precedes that. The temporal prefix is a one-dimensional list of symbols that is written by the author. The arrangement of the symbols is based on a particular theory of sorting. The order of the symbols in the temporal prefix is significant because sorting is possible with a binary string comparison. Basically, any program such as Excel or any programming language that uses greater than or less than can sort signs that have a temporal prefix. The temporal prefix is neither formatting nor style, and it represents meaning that is not found in the spatial sign box. Now, the spatial sign box is a two-dimensional cluster of symbols. This is what we see when we actually read sign writing. The position of each symbol is determined by the writer and defined using Cartesian coordinates that represent the top left of the symbol image. Two-dimensional space does not have a normative one-dimensional order. But when symbols overlap, the relative order of the overlapping symbols is important. Symbols written first appear underneath symbols that are written later. Otherwise, the exact string order of the spatial symbols is unpredictable. The spatial sign box is neither formatting nor style, and it represents meaning that is beyond the temporal prefix. All right, let's take a look at this FSW two-part word. In line number 1, you can see the string that is our FSW. In step number 2, you can see that we divide it, and we divide it starting at the M, which is our middle lane sign box marker. In step number 3, we take our time element, and we can see that it's actually the letter A followed by several symbol keys. When we go down to the space, we can see the M, then we can see a 3-digit number, X 3-digit number, a symbol key, and you can see that repeats. At step number 4, we can see that the time is just a sequence marker in a list of symbols, which is what we said it would be. The space, we can see that those numbers are actually XY coordinates. And finally, in step 5, we can say that it's the middle lane sign box marker. After the sign box marker, we always find the max coordinate. I'll explain that soon. And then we have a list of symbols with the top left coordinates for each symbol. Because we are placing two-dimensional writing, every symbol has a position. We can look at the same word in SWU, and you can see that it's a lot more visual. We break again at the sign box marker of the M. You can see the breakup in step number 2. At step number 3, we can already identify that, yeah, that's a sequence marker with a list of symbols for the time. Now for our space, we can space out the numbers and the symbols. At step number 4, we can change those numbers into actual XY coordinates. And then again, we can identify, we have the middle lane sign box marker, the max coordinate, and then we have a bunch of symbols, and each symbol has a top left coordinate associated with it. For punctuation, punctuation always occurs in the middle lane, and punctuation always occurs by itself. For punctuation, we only need the punctuation symbol itself and the top left coordinate. Now, for visual presentation, we need to have that max coordinate, and the max coordinate can just be defined by 1000 minus the top left coordinate. And you can see right here, the max coordinate is 536 by 504, and we're able to determine that using math. SW is the same. Again, it's going to be a single punctuation and the top left coordinate. And again, we can create that max coordinate by just using some simple math. Software development, we have 4 main packages. We have the Sutton SignWriting Core. It's a JavaScript package for Node and the browser. It supports the general processing of SignWriting text. All of the other packages rely on the SignWriting Core. Then we also have the Sutton SignWriting Font Database, FontDB. That is a JavaScript package for Node that generates SVG and ping images for individual symbols, complete signs, and structured text using pure SVG. That font database package does have a database. And inside that database, it has the entire International Signwriting Alphabet 2010, and it has pure SVG for each of the symbols in our alphabet. And again, that is built using the core underneath. We also have the Sutton Signwriting font TTF. It uses true type fonts. It's a JavaScript package, and this is for the browser. And that generates SVG and ping images for individual symbols, complete signs, and structured text using true type fonts. It uses the Sutton Signwriting fill and the Sutton Signwriting line fonts. More on that soon. There is also the Sutton Signwriting SGNW components, the Sutton Signwriting web components. That is built on the font TTF and it's built on top of the core. It is a JavaScript package for the browser that includes a collection of web components built with Stencil.js. You can find all of our packages on github.com, and they are also published on NPM. After this presentation, I'm going to show some videos that highlight all of these packages with a lot more in-depth. We also have SignMaker available, which is an iframe editor using post message and add event listener. SignMaker is a complete editor that you can embed in any web page so that you can load, edit, and save signs. It's an online editor. It can be accessed directly, embedded in an iframe, and also downloaded to your computer. It uses both FSW, SignWriting, and Unicode, uses both character sets, and it also supports the associated style string. With this, you can send messages and receive messages from your web page. The links are below. Basically dive in, look into it. You can always ask questions. All right, for the visuals, we have a common SVG wrapper. And that means if you have a pure SVG sign or if you have a SVG sign that uses true type fonts, you will always have this common SVG wrapper. In step number 1, we have the spatial sign box written in SignWriting in Unicode, SWU. And step number 2, you see when we break that apart, we can get our max coordinate and we have all of our symbols with space. So our max coordinate is 525 by 535. Now the min coordinate is an XY, and we need to look at where each of the symbols is placed. We find out all of them and we find out the min coordinate for that. So in this situation, our min X is 476 and our min Y is 466. Now, once we have our max coordinate and our min coordinate, we can actually figure out our width, which is simply just the max minus the min. Now, when we look at step number 4, where we have our common SVG wrapper, you can see that we need to use the width, we need to use the height, and in the view box, we need to use the min X, the min Y, the width, and the height. You'll also see we have a text element with a font size of 0 that contains our original string. This is used, well, it's set to invisible because we don't want to see it, but it is there so that we can actually copy and paste the string out of our SVG. Now with self-contained SVG that we can get out of the font database, each symbol gets its own SVG group. You can see our first symbol in the list, which is just that looping arrowhead. It occurs at 483 by 510. And in our SVG wrapper for that individual symbol, you can see that's where we put it. We give it the X, we give it the Y. We give it a G transform to, it's really to SVG. But inside you'll see 2 path elements. And there's one for the symbol fill, which is the palm or the head of the arrow. And you also see a symbol line, which is the actual outline of the symbol itself. Each have a path, the D element, and that is for data. And like I said, that is a pure SVG element. If you want to use SVG in any types of graphic editor, or if you want to post signs, if you want to post signs online anywhere that don't require fonts that are self-contained, this is the type of SVG that you're going to want to create. We also have SVG with fonts. And for SVG with fonts, each symbol will get a G group. And rather than specifying the XY, we do a transform translate. And that is the XY position that we're going to write those on. Now, in SVG with fonts, each symbol gets two text elements. The one is going to be class with a symbol fill. The other is going to be a class with a symbol line. And for each of those, we tell it what the font family is going to be. It's going to be either the Sutton SignWriting fill or the Sutton SignWriting line. If you see the box with the question mark inside of it, the inside of our text element, those are actually plain 15 or plain 16 characters, because every symbol is one code point on either of those planes. When we're using our font for the SVG, we need to define our font families. We define each one separately. So we have the Sutton SignWriting line font family. And if you look in the source, you'll see that we have 3 different designations for where that font is. The first one is local, and that is a Sutton SignWriting line, and that is the local installed on your computer. So if you have the Sutton SignWriting line and the Sutton SignWriting fill fonts installed on your computer, when you access a web page that uses that font face, it will just automatically use that font you have installed. The second line, you'll see it begins with a dot. Now, this is for web pages or applications that actually embed the fonts in their product. And for that, it's going to look relative to the web page that you visit. And if those exist, it will use those. And finally, we have the URL that starts with the HTTPS. It's a really long URL that I didn't copy all of. But if you go to a web page that uses SVG with fonts for SignWriting and it can't find the font, it will actually go out to the internet, download that font, and install it into your browser cache for you to use. It happens one time for the entire web page. So once it's downloaded and installed in the browser cache, it will keep using that throughout your experience. So you may get an initial delay for when the font loads, but after that, it should be nice and fast for you. There is also something called the styling string. The styling string is fully supported in the Sutton SignWriting core. And with that, you can define whether a sign should be colorized. You can add padding, you can add background colors, you can change the detail line for the detail color for the line and fill. You can set the zoom level. You can even color individual symbols. And when you create SVG, you can specify class names, and you can even give that SVG an ID. When you look in the core package, you're going to see two functions that can really help you understand the styling string. We have the style.parse and the style.compose. In the style.parse, you can actually see our styling string. It's the -CP10G and so forth. Each of these elements is written in a specific order, and when we parse it, we can see that colorize is true, our padding is 10, our background color is blue, and our detail colors are red and cyan. Now, for the compose, we go in the opposite way. We give it an object where we specify everything that we want, and it will actually return that styling string for us. If you visit the documentation, you can find more information on the style string, and you can get a full definition of what is involved. All right, for searching, we have a query language for formal SignWriting. The query language is for formal SignWriting. It allows for precise searching of signs written in either FSW or SWU. A query string is a concise representation for a much larger and detailed set of regular expressions. The regular expressions can be used to quickly and accurately search large files and databases containing formal sign writing. Once you learn how to do it, writing the query strings is relatively easy. Whereas if you wanted to write the regular expressions by hand, it would be very difficult. So with our query language, we have several possibilities. We can search the temporal prefix or the spatial sign box. We can search for exact symbols, or we can search for symbols with any fill or any rotation. We can search for symbols near a coordinate within a specific range, or we can search for a range of symbols like any of the index hand shapes. We can also search for any one particular symbol within a list of symbols that we will give it. You can learn more. Again, the query language is fully supported in our core package. All right, regular expressions. What are regular expressions? Well, if you want to work with regular expressions in formal sign writing, here's all the basics that you need to know. The first character is the star, and that means match a literal 0 or more times. In our example, we have the ABC star. So that literal in this one, or this example, is going to be that letter C. So we're going to match it 0 or more times. So it will match AB, it will match ABC, or it will match ABCC, however many it goes on. We also have the plus, and that's going to match our literal 1 or more times. So our ABC plus will match ABC, ABCC, and so forth. We also have the question mark that will match a literal 0 or 1 times. So our ABC question mark will match AB or ABC. We have the curly brackets with the number, and that will match it however many numbers of times that you specify. So if we have our AB curly brackets 2, that will match the B 2 times. So ABB. We have our straight brackets, which will match any single literal from a list. So if we have square bracket ABC, that will match A or B or C. We also can match any single literal in a range. So if we have, in our example, square brackets A-C, that will match A or B or C. Also works with numbers. We also have parentheses, and that creates a group for matching. So in our example, we have A parentheses BC, close parentheses plus. That BC will be treated as a unit, and we're going to match that unit 1 or more times. So that will match ABC or ABCBC or ABCBCBCBC, however many times. We also can use the pipe character with our parentheses to match one of several alternatives. So in our example, we have the parentheses AB pipe, BC pipe, CD. That will match any one of those. So in this example, it will match AB or BC or CD. We also have something called non-capturing groups. That is the question mark colon. With regular expressions, when you match by groups, the programming languages will put that separate and will give you what groups it captured. When we don't want that to happen, we use non-capturing groups. That's very important to use in the core that we have available. And in our example, it will just match ABC as one group without actually dividing out that subgroup that it captured. So let's take a look at an example of searching for a number with regular expressions. Now, this is very important for our query strings because when we're looking for a symbol, we may not know the exact coordinate it is at. So instead of a specific number, we say we're looking for this symbol within this range of numbers. So if we wanted to find or match a number from 423 to 466, you just can't tell regular expressions to do that. What you need to do is you need to break it up into a series of incremental steps. So in our example, what we do is, well, we're going to find numbers from 423 to 429, and we can write a regular expression for that. Next, we're going to match numbers from 430 to 499, and we can write another expression for that. Then we're going to look for numbers from 500 to 599. We can write the regular expression for that. Then we're going to find numbers from 600 to 609. Again, another regular expression. And the last one to fill it all out. We're going to go from 610 to 612 with that regular expression. We put them all together with our parentheses and our pipe characters. And this regular expression will find any number in text from 423 to 612. Now we have some transformations. The first transformation is from formal sign writing to a query string. With this, we can say we have an original FSW, we have it up there, and we can automatically convert that to a query string that will find the exact symbols in the temporal prefix. We can say, well, just find general symbols in the temporal prefix. If you look at that, you will notice the characters UU. And that's a symbol string, and that means an undefined fill and an undefined rotation. It's basically a wild card. We can find exact symbols in the spatial sign box, and we can find exact symbols near a coordinate in our sign box. If you look in the core module, you can see we have a function that creates these query strings automatically. We also have the SWU to query string. So we can see that we have our SWU string, and we can create query strings from that SWU automatically using our functions. Now, when we have our query strings, we also convert that to regular expressions. So here we have a query string. First of all, if you see the S100UU, that's going to find the index hand. I just know what the symbol key is, and any fill, any rotation. And then the S205, that is a context star, and it's going to look for that at that specific coordinate or near that coordinate. And what it returns is it returns two regular expressions. With query strings, it can return one or more regular expressions, and we need to use a filter and repeat. So we would take our text, we would run it through the first regular expression, and that would give us a list of signs that match that. And then we would run the next regular expressions on what was returned, and that would give us our results. If you look at this, you can, the regular expressions on the screen, you can kind of understand them a little bit. We have the question mark colon, which says non-capturing group. We have our A. We know that is the sequence marker. Then we have a symbol key, which we can see. It always starts with the letter S. The next character is a 1, 2, or 3. The next is 0 through 9 or A through F. That is a hexadecimal number, and we need 2 of them. And then we have 0 through 5 for the fill, and 0 through 9 or A through F for our rotation, and so on. For our SW query string to regular expression, we can see that the query string right now, that is going to search the temporal prefix. We know that because it starts with the A. It's going to look for that specific symbol to start our temporal prefix, and the T terminates that temporal prefix searching part. So that's the end of it. Now, the regular expression that returned there is a little bit more difficult to read. One special quirk of JavaScript is that it uses UTF-16. There's UTF-32, UTF-16. There are different formats in Unicode. You're going to have to look into Unicode more if you want to be able to understand that. All right, and then we also have transformations of SFW. Sorry, we have transformations from regular expressions to our FSW or SWU. Those regular expressions that are returned, they are supported wherever regular expressions are supported. You can search extended text for matching signs written in FSW or SWU. With our transformations, we have a complete circle. We can go from formal sign writing to a query string to a regular expression, and that regular expression can be used to search for our formal sign writing strings. Well, would you like to know more? That's where I have the sign writing stream come in. With the sign writing stream, I'm going to show you some videos, and that is going to cover the core, the font database, the font true type fonts, and our sign writing web components. And it will discuss in detail more all of these ideas that I've been talking about. And I'd like to play those for you now. All right. There are 4 videos available on the Sutton Signwriting core, and let's give those a watch. Welcome to the Signwriting stream, where we show, teach, and demo all about Sutton Signwriting. Welcome to this episode, the Sutton Signwriting core package, part 1. We're going to talk about formal signwriting symbols and coordinates. Let's get started. First, all of the symbols that we use in signwriting are part of a set called the International Signwriting Alphabet 2010, abbreviated the ISWA 2010. We released this in 2010, and it's been stable since release. Signwriting, it's an unusual script because the symbols of the script, it's not used sequentially. It's used spatially in 2 dimensions. 2 dimensions, we're talking about X, Y coordinates. Most other scripts use a sequential list of individual symbols that may or may not morph and connect when they're used in combination. But signwriting is different because the writer decides the placement of the symbols on a 2-dimensional canvas. The symbols, let's take a look. We are going to explore the symbols, and we're going to check out the FSW character set. Here are all of the symbols. There should be 652 top level, and each symbol you can select, and you can see all of the fills for the palm changes, or you have the going down for the rotations. Each of these symbols has a unique name. This symbol right here is S100-2C. All of these symbols on this page are going to start with the S100, and then they'll have a fill value and a possible rotation value. You can scroll through the symbols, and you can access the 7 categories or the 30 groups. So, when we're reading signwriting, what we want to do is we want to see it properly laid out in lanes and signs. We're not there yet with our 2-dimensional font, but we have our character set of ASCII, FSW, and ASCII, and this is what it looks like. This is a live demonstration, so you can set the style. You can also animate it. This is what signwriting would look like if we had to telegraph. All right, we are talking about symbols. Let's check out 2 symbols that we're going to enter here. The first is just the first symbol in the whole set, which is S10000. Now, for that first index hand shape, we're going to do the last one as well, which is S1005F. So if we want to match these symbols, the first is we want to match the S character. We've got 2 matches. It's going to be followed by 100. So far, we can match both symbols just fine. The next thing is it can be 0 through 5. With regular expressions, 0 through 5. With regular expressions, we don't have to say exact characters, we can give a range. Or for this last one, we're going to do 0 through 9, and then A through F. And we found both A through F. And we find both symbols. All right, now we're talking about coordinates. For each of these symbols, it can appear at a position. Let's say 500 by 500. All right. So how do we match numbers? Let's clear that out. Now, if we want to match a number, we can do 0 through 9. And we have 11 matches. All right. But our numbers always have 3 digits. So we can use this special notation and say we want 3 of those. 3 of those. All right. Now, formal sign writing in ASCII, we don't use commas. What we do is replace commas with X's. So if we want to match a formal sign writing in ASCII coordinate, we match the 3-digit number followed by the X, and then we can follow it by more numbers. And we want 3 of them. And as you can see, we found our 1 match. Now this is also more flexible, so any coordinate like 480 by 520 matched as well. All right, symbols and coordinates. Let's go over to the core package. Sorry about that, scroll all the way up. Sutton SignWriting core package on GitHub. If you want to take a look at the source, you can take a look in the SRC directory. If you just want to get a release, you can go to the release and you can get the development source code or the distribution that contains the files that you'll use in your code. All right, the core package. You can see that there are 6 modules in the core package. 5 of them all follow the same pattern, and that is RE for regular expressions, and then there's parse and compose. We're going to look at the parse and compose functions for FSW. You can find some useful links. There's the source, there's the distribution that you can link live in your any web page or as well. We have our documentation, which is very nice. Let me open that up. Issue tracker, discussion. The core package, it's written in small ES modules and small functions. It's, like I said, in the source directory. We also package it up for distribution, and that's files that you can use for development. We have 3 different kinds. There's the UMD, or Universal Module Definition. There's CommonJS, and there's also the ES modules. You can take a look at our files, the extension JS, CJS, MJS. All right, let's do our first step, which we are going to download and install with npm, and that is npm install at Sutton SignWriting /core. So let's start that up. So npm install at Sutton core. All right, we had a complaint that we didn't have a package.json file, but that's fine. Let's take a look in our directory, and we can see it added a node modules. Let's take a quick look at that. So tree, node modules, we're going to do 3 levels. And in our node modules, we have our @Sutton SignWriting group, and then inside that we have our core, and inside that we have all of our files. You can see the CJS, JS, MJS. So you can pick what kind of file you want. All right. Let's go back to our instructions, and let's use it in Node. To use in Node, we're going to import the entire library, and that's going to be constant core equals require @Sutton SignWriting core. So let's copy the statement and get back here. All right, clear. So first we need to get into Node. All right, now we can paste our statement. And now we have our core function that we can check out. Let's do core dot, we're looking about FSW, and we want to check out the regular expressions. And you can see symbol, here's the full definition of a symbol, and a coordinate, here's the full definition of a coordinate. This should make a little sense because for a coordinate, we want a number 0 through 9, 3 of them, followed by an X, followed by a number 0 to 9, and 3 of them. And we make more complicated regular expressions that are all based off of basically just symbol and coordinate. These regular expressions are pre-compiled, but if you look at the source, let's go back up here to the distribution. We'll go in the source directory, FSW. Here are all of our small functions that get packaged, but we are concerned about fswre.js. Here's the entire regular expression set. Again, we have our symbol, we have our coordinate, we have our A for sorting, and we have our box for generic V box or left, middle, and right. All of our other regular expressions are actually defined using these 4 basic sets. So this is a prefix is a sort character, which is A, followed by symbols. If you see the plus sign, that means 1 or more. We can define spatial symbols, a sign box, sortable, all kinds of things. All right. So what shall we do first? Parse and compose. All right. core.fsw.parse.symbol. Let's do that first symbol that we were talking about. And it gives us 3 things. It gives us a symbol, it gives us a coordinate, and a style. Because if we were going to give it a full example, let's give it the coordinate 500, 500. Styling string we'll talk about later, but just to show you, when you parse it, it gets put into this object of symbol, coordinate, and style. If we're going to core.fsw.parse assign, let's go grab one from our website. We'll just grab this first one right here. Copy. So we're going to paste our sign in. Now, let's actually send this to a object. So we'll do that same statement. We'll just say var obj equals. All right, obj. Let's take a look at it. We have a sequence, and this is going to be used for sorting. And here are the symbol keys. Our box is M. Our max coordinate is 525 by 535. We have a bunch of spatials. Let's take a closer look at the spatials. obj.spatials. All right, we have a symbol, this symbol, at a coordinate, this coordinate. We have a symbol, this symbol, at coordinate. Symbols and coordinates, that's all it is. All right, let's take another look at okay. So, we have our object. Let's change our object. If we do obj.box, rather than being in the middle lane, let's put it in the left lane. All right, we change it, obj. As you can see, our box is now L. Now, like I said, parse and compose. We already parsed our string into an object. Now we need to return the object back to a string. So it's the same, core.fsw.compose.sign. And we just send it the object. Here is the string that is returned. If you notice, alphabetical, and right from here to there. That's our sequence. S10011, right there. S10019, right there. That's all it is. We look, our box is L, we updated that, followed by the max coordinate, which is right there. 525, X 535, which is basically the array of these two numbers. And then right here, we have all of our spatials. S2E748. Oh, that's right there. And that is at position 483 X5 by 510. All right. Well, that should get you started. Regular expressions, parsing and composing. For the Sutton SignWriting core, that's what we're talking about. We talked about today the FSW, formal SignWriting and ASCII character set, which is isomorphic. That means it contains the same exact values or same exact information as SignWriting and Unicode, SWU. Yeah, in future episodes, we'll talk more about the core package. If you have any questions, please stop by our Gitter or join our Facebook group, Sutton SignWriting. And I hope you ask me questions and that you join the community. You take care. Welcome to the SignWriting stream, where we show, teach, and demo all about Sutton SignWriting. Today, the Sutton SignWriting core part 2. We're going to cover SignWriting with style. Please, as ever, go ahead and join on the Sutton SignWriting community on Gitter for our open chat. Here are the websites that we're going to be looking at and going over. Let's get started. First, the code is available on GitHub, Sutton SignWriting core. Let's scroll down and see what we have. It has the source and all the instructions for building. But this is what we were talking about, the Sutton SignWriting core. 151 downloads a month. Really nice. Specifically, we're going to talk about the style module within the core package. And again, that follows the regular expression object, parse function, and compose function, the same as the other modules. Useful links. There is a source code on GitHub. We have the distribution, which I'll be showing you how to use in the browser. We have documentation, excellent use for referencing all of the functions. In the browser, we're going to be using just the plain JS extension, and that is the universal module definition. Last time we installed with npm, but we're not going to install this time. Last time we used in Node, but we're not going to use it in Node this time. We're going to use it in the browser. Rather than having local files that we need to download, we're going to use the distribution from unpackage. And we have this one statement right here. And we can place this in any HTML page that we want, and we can use our library. Let's see. Now, if you go to unpackage, you can see that we still have our source directory, but we also have the converted files and functions that are available. You can check this out. You can link to it directly. If you just wanted to use style by itself rather than including the whole package, you could just grab the style.min.js, and that is only 3.44 kilobytes. We have excellent documentation available. Specifically, we're going to be doing the style module. And we're going to get into the regular expressions, the parse function, and the compose function. All right, let's take a look at the style before we get started. This is just steveslavinsky.me/demo/fsw.html. So let's just look at a simple style string. The simplest style that I like to use is -C. And if you noticed, that first sign right here, that sign is actually having the style applied. So we're going to make it colorized. We can't really see it, so let's do a Z4 for zoom 4. There we go. I can't really see the strings up here, so let's make this bigger. We'll get rid of all the rest of the text. We'll make this page bigger. And here is our style string. We have dash C for colorize and dash Z4. And that is zoom 4. Now, the style string is very peculiar about the order. So let's take a deeper look. This is a simple web page that I made. Doesn't do anything ready yet right now. So let's go and edit the HTML file. It's a simple HTML file. We just have a title. I made up this one function just to print, just to make things easier. And here's our script that just calls that print function. First thing we need is that script tag that we copied, so we can just paste that in there. And now we're ready to use our library. Let's see what we have. The first thing, we'll just see if we have our regular expressions. So we are going to pass that the Sutton SignWriting core style regular expressions. Save that. Now when we run that, we get all of our regular expressions for colorize, for the hex color, color names, padding, zoom, and on and on. So let's go ahead and set up a variable. A little bigger maybe. We're going to set up a variable style, and we're going to make that equal to, we had that dash C, Z4 for colorize and zoom 4. Now if we're going to print, we can just say style, and we'll pass in the style. And then we'll have our object equals Sutton SignWriting core style parse. We can send it that style string. And then we're going to print our object, which is just simple OBJ. All right, let's see what that did. Refresh our page. Down here, our style of dash CZ4, and the object we get out says colorize true zoom 4. All of the options are in the documentation. We'll get there in a second. Let's take away this print. Now we can also give it a background of yellow. Let's see what that looks like. And you can see our object, once we parse our style, our object starts filling out more. Colorize true, background yellow, zoom 4. Let's go to the documentation, and we will look at the compose function. Now the compose function does the opposite. It takes an object and it returns a string. So let's check that out real quick. Let's see, we're going to have our new style equals Sutton SignWriting core style.compose, and we'll give it the object. Let's save that. Yeah. New style. Let's print it. There we go. We start with the style string, we parse it to get our object, and then we take that object and we compose it back into our style string. Now we started and ended both with the same style string, but let's actually update our object. Right here, we're going to say object dot padding. That just takes a number. Now let's see what happens. When we refresh, we start with the style string, we parse it to an object, we take that object, we add the background, we add the padding, and we added the padding of 10. Let's actually take a look at our new object too one more time. So our object starts like this, colorize background and zoom. We added the padding of 10, And when we take that object and compose it, we get our new style. Let's go ahead and copy that. And we'll just put it at the background there. And you can see this is our style. So that is SignWriting with Style, the Sutton SignWriting Core Part 2, when we covered the style for regular expressions, parsing, and composing. I hope this was informative, and we'll see you again. Welcome to the SignWriting stream, where we show, teach, and demo all about Sutton SignWriting. This episode, the Sutton SignWriting Core, Part 3, Searching with FSW Query. As always, go ahead and join our open chat on Gitter. We'd love to hear your comments and questions. You can find the Sutton SignWriting Core on NPM. If you scroll on down, you'll find some useful links. We're going to be looking at the source on GitHub and the documentation on github.io. For the source code, you'll want to go to the source directory, and for this, the FSW query folder. And this folder has all of our functions with the function definition and the associated tests. For the documentation, we just care about the FSW query section. And you can see our regular expression object and our parse function, our compose function, and all the other ones and how to call them and what they return. Let's take a quick look at SignMaker 2017 and how we search there. Scroll down, find your country of interest, go ahead and open it up. Now in this top section here, we can use English if we want. We can search like hello or world. But we can also use something called the FSW query string. Let me just type this in here. I'm going to search for all signs that have a contact star. And you can see that we found 55 pages, and all of these signs have our contact star. But let's also search for the two-hand shape. So we only have these many signs. And all of these signs, you can see, have the two-hand shape and a contact star. If we want, we could also say, I don't care about the fill of the rotation. And you can see that we still have the two-hand shape, but now it is in different rotations and with different fills. We're going to be using this in Node today. So the first thing we need to do is we need to install it. We can install Sutton SignWriting Core with npm install Sutton SignWriting Core. Open up a terminal window, paste in our install statement. Think. It is installed. Let's start up Node. Now to use it in Node, back to the documentation, usage in Node. Const core equals require Sutton SignWriting Core. Again, we can just paste that in, and now we have our core module. We're specifically interested in the core FSW query. And we can see all of our functions. All right, let's get a sign here and start playing around. steveslavinsky.me/demo/fswhtml. I will take this first sign. If I double click on it, I can do a right click and copy. So our sign equals, and I can put that sign that I copied in there. All right, there we go. Now, back to the documentation. I'm going to be using the FSW2query function, and that is a function to convert an FSW string to a query string. It takes several flags. You can search for the exact symbols in the temporal prefix or general symbols in the temporal prefix. For the sign box, you can search for exact symbols or general symbols, and you can also search for location. So let's get that started, and we will say Q for A, and that is query string for exact symbols in the temporal prefix. So we go core FSW query.fsw2query. I pass it my sign, and I'll just pass the capital A. And there is my query string. It's Since I'm searching the temporal prefix, you can see that this first part of our query string matches exactly the first part of our FSW string. Now, if we did a lowercase a instead, we can see that it's not the same, but we have this UU, and this U means undefined, the first one for the fill, the second one for the rotation. All right, we can copy these query strings, and we can actually paste them into SignMaker if we want. And paste. So what it did is it found two signs that match our query string. If we look at them, we can see that they do both indeed start with the same exact sign spelling sequence, or the temporal prefix. Let's take a look at our second one. And this is for the temporal prefix with general symbols. And we have a new sign that appears. And this sign does not start with that same exact symbols in the temporal prefix, but you can see that that first symbol and that last one is actually rotated. And because we said we just want the general symbols, it was able to find it. We can also search the sign box. So let's use a lowercase s. And again, we see that UU. And we'll do a capital S. Capital S says search the sign box, the exact symbols. All right, let's search for just the general symbols and see how many signs we get. Pop that in, and we get a couple new ones. And you can see that the reason that this one didn't show up before is because it actually has a different prefix, because we were looking, all of these have that prefix, but this one, these last two change. So when I search the sign box, it finds it. And we can see that as well as the bottom. This one doesn't have any temporal prefix. So if we search the temporal prefix, we're not going to find this sign. But since we're searching the sign box itself, we do. Now, we can also use the query string and transform it into a regular expression. So let's do that. All right, so query equals core FSW query dot FSW to query. I'm sorry, one more time. Let's just call core.fsw query. We want the regular expression. And let's give it the our sign. No. QA. Because QA is this query string. This query string has this regular expression associated with it. Regular expressions, when they're returned, can be one or more. Let me copy this regular expression. All right, regex101.com, regular expression tester. Copy and paste our regular expression up top. We need some text that we can search. Go back to the FSW demo. We'll select all of our text. And when we paste that in here, you can see that it reports it found one match. That one matches this right here. And we can copy that sign. And if we go back here, paste it in, you can see that is the sign that we were searching for, and we did indeed find it. Now, some query strings will return multiple regular expressions. So, core.fswquery.regex. Let's see. New query string for S10E U S20500. And that is search for the two hand shape, any fill, any rotation, and the contact star. And you can see that we get two regular expressions returned. Let's copy this first one. Now, when we go back to the regex 101, we paste that in, it finds three matches. We have this first one here, scroll down, the second one, and this third one. And you can see that we were looking for the index, or the two-hand shape, and that's this right here, the S10E. With our second regular expression that was in here, you can paste that in. And this is going to find all the signs that have the contact star, and that's S20500. And there it is again. Now the results for the signs that match are going to have to match both of our regular expressions, and that's why we use a filter and repeat pattern, where we search our text and it returns the text that matched, and then we search that resulting matched text again. If you go to the documentation, you can use the FSW query results and the FSW query lines, and that has the built-in filter and repeat patterns. So you don't have to worry about the regular expressions at all. You just pass the query string and the text that you want to analyze. All right, there's also another part, which is ranges. Let's talk about this. S10000 is the index. The S10E00 is our two-hand shape, but we want the one right before that, so we're going to just go to D. Now let's say we wanted to find symbols that were between both these ranges. What we can do is first divide it apart. We don't need the S in the front, and we can take off the fill in the rotation. Same thing for here. So for a range, capital R, and then the first base, and then small t, and then the second base. We don't need the filler rotation because it's going to include them all. Prefix it with a Q to make a query string, and we can copy that and paste that right into SignMaker. And what this is going to do is it only returns 55 pages, and it only includes hand shapes that are the index or in that first group. And you can see a little bit further. Here we go. It matched this because this symbol is between those ranges. All right, but ranges are a little bit difficult, and query strings can be a little bit difficult to write. So let's just use something called the click search. Click search is a way to build query strings using the symbol palette. Now, if we just do a one click, all of these are now clickable buttons, and when you click on them, it's going to say, okay, well, let's find all the symbols that are in here. And that will include all the symbols that are underneath the symbol, saying it comes up with a range. So any symbol that's in this group and anyone that has the contact star. And you can see all of our signs, no matter how they are written, will include a hand shape. Here's right here that's in that first group, and the contact star. We can also do a two-click click search. And with that, we can click on the index, and we want this right here. And it shows you the viable options. And I want this arrow, and I just want the small one. And this is actually the sign I was looking for, to dream. Clear it out. We can also do a three-click search. Now this, I want this one, and I want this hand shape. And you can see that all of these signs have that exact hand shape that I selected. You can also do it for that hand shape and the contact star. So I hope that gave you a good idea of what you can do with the FSW query. Check out the documentation. Join us on Gitter to ask some questions and give feedback, and hope that you enjoyed it. Thanks for watching. Welcome to the SignWriting stream, where we show, teach, and demo all about Sutton SignWriting. This week, Sutton SignWriting Core, Part 4, SignWriting in Unicode. As always, go ahead and hop over to our Gitter open chat. I'd love to hear from you. We got some great feedback and some great input. You should check it out. We've talked about formal sign writing in ASCII before, and that is what these characters are up here. This is the encoding that we use. It needs to be transformed so that you can actually get the visual output for reading. Sign writing in Unicode has the same information, but it's a lot more visual. And this is our actual text. If we look down in here, we have the same output. Unicode, a little bit complicated. There is an excellent YouTube video you should watch. It's about half hour, but it's called Pragmatic Unicode, or How Do I Stop the Pain? You really need to know about UTF-32, UTF-16, and UTF-8. Unfortunately, JavaScript does use UTF-16, so it has some extra complications, but we'll get into that. We are going to be using the SignWriting core for this episode. We'll specifically be focusing on the SWU module, which has all of these functions. There's also the convert module that we'll be using. It has additional functions to use. And if you look up for to SWU, you can find all the convert functions that convert to sign writing in Unicode. Or you can do the opposite of SWU to find out all the functions where sign writing in Unicode can be converted into other things as well. The first thing that we need to do is get the font for the sign writing in Unicode. You can go to the Sutton SignWriting project and go to the font page. On the font page, the font that we're going to want is the Sutton SignWriting 1D font. You can easily install it on Windows, Mac, and Linux. There's also instructions for installing on iOS. In case you people don't have the fonts installed, we have a CSS statement that we're going to copy here. And we'll be using that. If you go over to codesandbox.io, and we're just going to create a vanilla sandbox. This is an excellent website where it actually gives you a VS Code editor that you can use. The first thing that we're going to do is we're going to go to the style.css. And we are going to paste our font face so that we can access the Sutton SignWriting 1D. We're going to want to copy the name of that font, and we're going to want to replace the font family for the page. All right. Go back to the index page. Now, just to make things a little bit easier, I'm going to change this statement here into a function. So we're going to let append equals, I'm going to pass it some text, and we're going to give it to the function. We're going to do document get element by ID with app. We're going to set that plus equals to, and it's going to be our text, plus, we're going to just pass it a line break. All right, so we have a dependency. So we're going to go over here, scroll down to add dependency. We are going to be using the Sutton SignWriting core right there. It's loading, perfect. Now, before we can use it, we need to import it. So we're going to import star as core from at Sutton SignWriting. All right, now we can use it. Let's start with the first one. We're going to say let ID equals 1. Every symbol in the Sutton SignWriting font has an ID, and this is going to be the first one. So then we're going to let SWU equal to, now we need the core.convert.id to SWU. We pass it the ID. Now let's append our SWU. And we can see that we have our symbol that appeared. Let's make that a little bit bigger. I'll go to the CSS. We'll do a font size. Let's do 45 px. Excellent. Now, we can do the same thing for FSW. So we're going to let FSW equals core.convert.id to FSW and pass it the ID. And we can also append FSW. No, what don't you like? It's ID to key. All right. So if we look at these, we can also get the length. The length of our SWU is 2, but the length of our FSW is at 6. Now it's pretty easy to see why the length of our FSW symbol key is 6. You can just count the characters. But when we try to count the character here, it's actually only 1 character. And that's because every character in SWU actually needs 2 characters of UTF-16. Now we can also say type of. What is the type of SWU? That's a string, just as the type of FSW is also a string, because we are dealing with text here. Now, like I said, this is our text, so we can actually copy this, and let's change it. So let's say SWU equals double quotes and paste in our character. Now you can see our SW character actually did show up in our text editor. This is VS Code. What you're going to want to do to see this is File, Preferences, Settings. And in the settings, if you search for font, you can see that I added Sutton SignWriting 1D to the font family that the editor uses. And that's why in our file, we actually can see our SignWriting in Unicode character. All right, let's get a bigger string. So we'll take this first sign, we'll copy that. Let's get rid of everything, we paste that in. Oh, I didn't grab the whole string. There we go. We'll go back over to our editor. Now we're going to say SWU. We're going to put the whole string in there. Let's see. What should we do that's fun? Well, there's just the convert. So we're going to say FSW equals SWU to FSW. We pass in the string. And we can see that they both are strings. Here's our converted string, but we can also do that length of. Length of 40 and dot. And our FSW is length of 85. Let's see, one last interesting thing to do is there's an encode and a decode that you can use with the core package. So let's say that our encoded value equals core.swu.encode. You pass it the SWU. There we go. And so let's check that out. Append encoded. And you can see we have a very long string. Let's simplify this, and we're just gonna bring it down to that individual hand shape. Oh, we can actually just get rid of that. There we go. So here's our SWU character. It is 2 characters long, and these are the actual 2 characters. This is called UTF-16. What we can also do is we can let decoded equals core.swu.decode. We can pass that encoded value, and then append decoded. And you can see that we get our string back. So this is SignWriting in Unicode. I totally, I would urge you to go watch this Pragmatic Unicode, or How Do I Stop the Pain, because it really does explain a lot of the concepts. Also, when you are looking at the SignWriting core module, you can check out all of the SWU functions, and all of them are well documented with examples and descriptions, how to use it. And then at the end, there is also that convert module. And the convert module, you can take individual parts of the SignWriting in Unicode, and you can get all of the pieces and the parts that you need. So, thanks for watching this week's episode. If you have any comments, questions, feel free to join our Gitter, and we'll see what we can do. Take care. All right, so that was the first package out of the 4 that I'm going to cover. That was the Sutton SignWriting Core.
Okay. That was a lot. Are you going to show us more?
I got lots more.
Lots
One thing
more.
that's kind of interesting, I saw when we were looking at the core package, that the first time I had the video, it said it was downloaded 100 and something times, and then it was 2, then it was 3, then it was 400 times a month. Well, if I look at it now, let's go see what we have. We go up to GitHub and go to the Sutton SignWriting Core. There we go. Scroll down. We have 3,000 downloads a month for the Sutton SignWriting Core. Very nice. I'm glad that people are finding it useful.
Yes, that's very impressive. It just shows you how the internet is helping so much to spread your information and everyone's information. And then the information builds and builds and builds, right? It's exciting.
It does. All right, next up, we're going to discuss the Sutton SignWriting font database.
Font database. I knew you were looking at me, so database, right? Anyway, the point is we're going to see something now. So go ahead and show it.
No, let's get to the right share screen. We have 2 videos here to watch, and let's play. Welcome to the SignWriting stream, where we show, teach, and demo all about Sutton SignWriting. This week, the Sutton SignWriting font database package for Node. Let's get started. As always, go ahead and join us on our Gitter open chat in the Sutton SignWriting community. Questions, comments, or any issues that you're having, be happy to help you out with. You can find the font database package on GitHub and NPM. We have extensive documentation, which we're going to take a look at right now. If you have an existing project you're working on and you want to use a font database, you can just do an npm install Sutton SignWriting font database. We're going to be using this as a standalone, so we're just going to go ahead and clone the Git repository. After we clone it, we're going to need to install the dependencies, so we're going to change directories into our new directory, and then we're going to do an npm install. All right, so git clone, we're going to do a cd font database and then an npm install. This is going to take a few minutes, so let's go ahead and back to the documentation. We'll take a look at our first function, fsw symbol svg. Now this is only for Node. You can't use it in a browser because it needs to use the file system. There's the ISWA database that it accesses. And you'll notice that our function does not actually return a value. Instead, what it does is the processing can take a little while. So it says, give me a callback function. So when the value is ready, I'll send it back to you. And this, we just have a simple callback function where we're going to say, if there's an error, we'll print out the error. Otherwise, if we have the result, we'll actually just print out the result and tell you what the SVG is. As I was saying, this is only for Node. Can't use it in the browser. If you're going to be in the browser, you need to use the TrueType fonts. Let's take a look at the TrueType fonts real quick just to see the differences. Let's get rid of everything except for that first sign. Perfect. This sign right here is created with our TrueType fonts. We can actually take a look at it and we can inspect the element. So here is the SVG that we have created with, this is the TrueType fonts. When we open that up, we can see our text, and inside that text is our FSW string. And then we have these G transform, G for group and transform for the position, the XY values. When we open that up, we actually see we have some text inside. And we have a fill and a line. And this is the outside line and also for the palm facing that we have actually right there on the inside of our symbol. Let's go ahead and go a little bit further and we'll do a view page source. And you can see right here, we have our font face, Sutton SignWriting line, and Sutton SignWriting fill. These, if the fonts are installed on the user's computer, it will use the Sutton SignWriting line. If the fonts are not installed, it will install them from a URL. However, the font database is different. It does not need to use the TrueType fonts because everything is available on the server. All right, everything's installed. We are good to go. We can take a look at the directory. We can see a few, and here is that database folder. So let's do an ls LTR database. You can see ISWA 2010, it's about 43 megabytes. All right. Now the first way that we can use, our package is we can use it in code. We can just say the constant font database equals, and we require that package we loaded. Or if we don't want to use the whole package or the library, we can just install or require a certain module. What I'm going to do is I'm going to show you how to use it on the command line. Using on the command line is really simple. Node, which is our programming language, and then what we want to use it with. Let me take this whole command and just copy it. And go back to our command line. So we can paste in that command, and we're saying with Node, run the FSW sign SVG with this FSW string, and it returns our SVG. You'll notice in the SVG that it does not have that group and those texts. Instead, what we do is we have paths. We have our fill here, and we have our line as well. And if you look at the path data, you'll see that it is all data. This SVG is standalone. You don't need any TrueType fonts to use it, and it can be used in any SVG application that you want to use. Similarly, we can do node, FSW, symbol, SVG, and we can just pass it whatever symbol key we want, and we will get this standalone SVG returned. You can also put another one where we can have output.svg, And when we list our directory, we can see our output SVG right there. This also works for ping. So if we want to do node, FSW, symbol ping, that's 205.0.0. And it will actually give us our data image that we can use in HTML, or we can redirect that to a file, out.ping. And then there we have our ping image that we can use. Also, it comes in with a built-in server that you can use for applications or apps if you're running Node within there. And that is just as simple as npm run server. npm run server. Now this is going to be available at our local host. So we can open that up in a browser as well. We can say localhost at port 4200. And here we have just a general information here, and it has a bunch of links. So if we wanted to have a symbol image in SVG, we can see that it's localhost FSW symbol SVG. Let's get that a little bit bigger. So we'll give it a style string of zoom 4. Now, if we did an inspect element on this, we would see that we have this SVG, and we have our groups, and we have our path data. Does not require true type fonts or anything like that. Rather than SVG, we can also do ping. Let's give it a background or a padding 10. There we go. There's our image, and when we look in there, we can see that it is actually using an image, and our source is right here. So you can use this server to generate symbol images or sign images. So that's just a quick demonstration of how we can use, thanks Val, how we can use the font database package. I hope that this is helpful, and I hope that you can use it. Welcome to the SignWriting stream, where we show, teach, and demo all about Sutton SignWriting. This week's episode, SignWriting in Unicode characters and the font database. Let's get started. As always, go ahead and hop over on gitter.im in the Sutton SignWriting community. You can find the links and discussions. Love to hear your comments and questions. This week's episode, I've actually created a script for. You can find that on github.com/Slavinsky. It's the SignWriting stream, series 1, episode 10. First, what I'm going to do is I'm going to copy the clone link, and I will get started in VS Code. We're going to do git clone and paste in our link. All right, that created a new folder, so let's open that folder. It's on the desktop, and there we go. Take a look at the README, and VS Code has a nice preview, so we can get a HTMLized version. You can find the link to the documentation for the font database. In this episode, I used the VS Code editor, the Bash command line, the Node runtime environment on Windows 10 with a Linux subsystem. To get started, we need to clone the repository for the font database. We can copy that command. We'll open up the terminal. Paste in our git clone command for the font database. Give that a minute to think. We can keep reading. We need to enter our new directory, and we need to install it. It will take a while, so let's get that started. We can cd to our font database, and then npm install. This is going to install all of our dependencies for us. So while that's thinking, we can go ahead and keep reading. We're going to be using the SignWriting in Unicode character set. I what we need to do is we need to install the Sutton SignWriting 1D font. And you'll notice that later I'll also be using the Firefox browser. To use the SignWriting and Unicode characters for development, we need to take a few steps. Rather than seeing these empty boxes, we want to see our actual characters. So what we need to do is we need to install the Sutton SignWriting 1D font. We can open up this link right here. All right, here it is. Available fonts. You can add the Sutton SignWriting line font and the fill font if you want, but for this episode, what we need to do is install the Sutton SignWriting 1D font. This is a true type font. We're going to save it. It's going to download, and once it's downloaded, we can open our file up and install. Should only take a second. There we go. Excellent. Now, the second thing we need to do is we need to configure VS Code to properly display our SignWriting and Unicode characters. What we need to do is go under File, Preferences, and Settings, and we're going to search for Font Family, and we're going to append our Sutton SignWriting 1D to the list of fonts. So File, Preferences, Settings, search for Font, and here's our list, and we do comma, Sutton SignWriting 1D. Excellent. Now we're still installing, so let's keep on reading a little bit. Oh, let's explore the database. So let's go into our font database directory. We can take a look. Oh, let's ls instead. Make that a little bigger. Here's the one directory we're concerned about. It is the cd DB, which is our database directory. We can see that there are 3 files in here. We have our JavaScript for our functions, and we have our ISWA 2010 database. Let's do a long listing on that so we can see it's about 43 megabytes big. Now to explore the database, we can use SQLite 3 because it is an SQLite database. So we can do SQLite 3 ISWA 2010 DB. So there's a couple commands we can do. We can do a .tables, and you'll see that it only lists one table, and that is the symbol table. We can do a .schema for our symbol table, and you can see that we have an ID, a sim key, width, height, and the SVG. So let's select sim key, comma, SVG from symbol where ID equals 1. And you can see we have our symbol ID, or sorry, our symbol key of S10000, and here is the inside of our SVG that the font database uses. All right, that's all that we're going to show in our database. So, now that we actually have the font database installed, let's shut down VS Code and let's open it back up. I'm going to open that with code. There we go. Let's look at the README. Right. Now, when we scroll down in the editor, we can see that our SW characters are installed, so we can actually see them in the editor, which is very nice when you're programming. If you notice over here, we still see these boxes. That's because sometimes you need to add some cascading style sheets to tell it exactly what to use. Right here, we can see that. We're using a paragraph, and we're telling it the style, font family, Sutton SignWriting 1D. And when we use that, our preview of our Markdown file does in fact show our characters over here. All right, explore the database. We already did that. The functions. All right, let's cd into our font database. Now we can do ls swu. Make this bigger. And you can see here are all the functions that we can use. Now, if we're just concerned about making individual symbols, we can use the symbol SVG or the symbol ping. Let's scroll down further. What I want to do is show an example of using the sign. I'm going to scroll this down all the way here. So this is the command I wanted to copy. Node, saying run with node, the SWU sign ping. Here's the string I'm giving it, and I'm also giving it a style string, and I'm telling it to save it to a file. Copy that and paste that in our directory, and when that runs, we can actually look at the file system in the font database, and there's a new file called black.ping. We open that up, we can see our ping image that was created with our library. All right, there's also a server that we can use. This is an example server to show you how to use the functions. And all we need to do is we need to list what's in the server. And we only have two. We have an index HTML file we can look at, and we also have a server.js that has all of our code. Let's start up the node server. So node server, server.js. This is going to run a local server that we can actually view on localhost 4200. Let's go back to Firefox, go to our page and refresh it, and here we can see that it is the Sutton SignWriting font database server. Let's scroll down to the SignWriting and Unicode functions. Let's take a look at a sign. Click on our SVG sign symbol, and it will go to a new address. It is localhost 4020 SWU sign SVG, and it actually gives us our SVG. We can do a view source, and you can see inside we do have our SVG. We can see our text that we gave it in SWU, and we can see each of the individual symbols placed at their respective XY coordinates. In VS Code, go back to the file system, and we are concerned about, in the server directory, the server.js. Our server.js is an example. We're using the FSW functions, which is part of the font database, the SWU functions, by doing a require. We're using the FS node, which is just the file system. We're using an HTTP server from node by just doing a require HTTP. And we're also including the URL module so that we can parse URLs. We have our prefix for XML. You just need that so that the browser will display that properly. And then we start. We say our server is an HTTP create server, which has a request and a response. We're going to parse our request, giving it that URL. And that URL is what is up here. Localhost, SWU, sign SVG. So what we need to do is find the SWU sign SVG. We have case here we don't need. And we keep going down until we get to the SWU. Now we have SW symbol. And here it is, SW sign SVG. To create the SVG we're going to be using, we use the SW module that we imported before with the require statement. We're using the sign SVG, and we're going to pass it that parts 4. That parts 4 is actually the SWU character string that we had sent. And you pass that into a function with an error and a result. If there's an error, we'll just log it to the console. But if there is a response, that will mean that it did send us back an SVG that we can use. We just tell it the header, which is an image SVG. We write the prefix, which every SVG needs to display properly, and then we just write the response. And that response that we wrote is that response that is right here. So that right there is a quick introduction of using SignWriting and Unicode characters in our editor. and with the font database package. I hope that this was useful. Comments and questions, please join our Gitter. Thanks for watching. All right, so that was our second of 4 software packages, the Sutton SignWriting Font Database.
Database, I guess it's a DB. Anyway, so then what?
Right. Well, one thing about the font database is that since this initial release, I have updated it. If you looked at that, you saw it used callbacks, and now I'm using async and await. It is just a different programming technique.
Await, AWAIT, right?
Right. Yeah. And it also they're also it's sometimes called promises. So you can use async and await or promise.
Okay.
And it just makes the code a lot cleaner, a lot easier. Just if you go looking in the code and the examples, you'll see the updates.
So you'll see, you can go up and look. You'll
What it
see.
is, how it works.
Oh, later, we're gonna get interpreters, I promise you. This is funny. I hope you can understand me. Okay, let's go ahead.
All right. The next software package is the font data. Sorry, the Sutton SignWriting True Type fonts. We have 2 to show for this one. So let's get these up and running. Welcome to the SignWriting stream, where we show, teach, and demo all about Sutton SignWriting. This week's episode, the Sutton SignWriting True Type font package. Let's get started. If you'd like to join our open chat, go ahead and go over to Gitter and to the Sutton SignWriting community room. We'd be happy to answer questions, comments, or anything else that you find interesting. We're going to be talking about the Sutton SignWriting Font TTF package. The source code is available on GitHub. We scroll on down, you can find some useful links. And we're going to specifically be looking at the documentation, also available on GitHub. If you look at the functions available, you can see that it's broken into 3 sections, 3 modules, if you will. We have the font module, the FSW module, and the SWU module. You can see the variety of fonts. All right, when we scroll down the documentation, you can see how to install it, which we don't need to do. We can see the usage, which is what we're going to look at. Rather than a module, we're going to use it in the browser with the unpackage link. All we need to do is copy this right here. We can copy that, and we can use it in our scripts. All right, have a blank directory right here. What I'm going to do is I'm going to touch index.html. And since we need a web server, I am going to npx serve dot. All right, that's going to take a minute to load up. We want to take a look at our index file over here. Okay. Our web page is ready. We can load it up. Nothing there because we're about to start it. All right. We just need a generic web page frame. There we go. And we can start right here just with our scripts. All right. Yeah, we copied the statement. Now we're going to paste it. Paste our script. There we go. And we're ready to go. Now, let's look at the documentation. You can see when we import the entire library, it's going to be available as ssw.ttf. In our script tag, we do ssw.ttf. Now, what do we want to use? All right. The first thing we want to do is the font CSS append. This appends the font face for the Sutton SignWriting fonts. This will either use the fonts that the user has installed on their computer, or it will actually download the fonts from the internet. You can do this manually, but the CSS append function just makes it easier. So font.css append. Now, if they don't have their fonts installed on the computer, it's going to download it from the internet, so it's not going to be ready immediately. So we have a secondary function we're going to use, which is ssw.ttf font CSS loaded. And that takes a callback function. And this callback function will happen once the fonts are ready. All right, let's put a little bit of HTML in here. We're going to use size. We're going to do SVG. And we're going to do hang. All right, for size, let's give it a div, an ID of size. And we'll need a div with an ID of SVG and a div with an ID of ping. All right, the first statement we want to do is we're going to do document, get element by ID, get the ID of size. We're going to set the inner HTML. All right, I want to do Sutton SignWriting, true type fonts. This time we're going to use the FSW module, and what we want is we want the symbol size. We just pass it the symbol key. Okay, let's take a look, see how we are doing. All right, our size is 15 by 30, width and height. Excellent. Let's get to the next one. What we want to do is we're going to set the symbol. We're going to set the get element by ID, the SVG, and rather than symbol size, we'll use symbol SVG. Okay, refresh. Perfect. One more to go. We're going to do ping, but this time let's do a style string. So colorized and zoom of 2. You can get element by ID of ping, and we're going to do the symbol ping. Now when we refresh over here, we'll see that we get this data string because the ping works a little bit differently. So let's modify, rather than doing a div, we're going to do an image. And rather than setting the HTML, we're going to set the src. And when we go over here and refresh, you can see that we have our ping image. If you want to do something, you can do an inspect element, and you can see that inside of our div of SVG, we do in fact have our SVG, which you can go through and look at all the parts. And inside of our ping, image ID ping, you can see that our source has been set, which is our image up there. So that's a brief overview of how we can get started with the Sutton SignWriting TrueType font package. If you have any questions, comments, drop by on Gitter. We'll see you next time. Welcome to the SignWriting stream, where we show, teach, and demo all about Sutton SignWriting. This week, the Sutton SignWriting TrueType font package. Part 2, sign normalization. Let's get started. As always, go ahead and hop over to our open chat on Gitter. Love to hear from you. Questions, comments, always welcome. We're going to be talking about the Sutton SignWriting TrueType font package. You can find it on npmjs.com or GitHub. Let's take a look. The documentation is available on github.io. And the functions that we're going to be looking at today is specifically the fsw.signNormalize function. First, when we're talking about signs, each sign is written in its own unique sign space, if you will. It is where we have x and y, xy coordinates. They range from 250 to 749 but the center of the space is always going to be 500 by 500. If we take a look at this sign, it starts with the sign box lane. For this, it's the middle lane. So we have our position of the 500 by 500 for the center. We have our pre-processed max coordinate. In this case, it's 514 by 517. That's placed there as well. Now we have two symbols that we're going to be putting in this sign box. We have the hand shape at the coordinate 490 by 483, and we have a contact star at 486 by 506. Sign normalization guarantees that the center is always going to be 500x and 500y. And it will position the symbols accordingly, and it will also pre-process that max coordinate for us. The center of a sign is very important. If you look at these signs, you can imagine a tight bounding box around each of the signs, and the center of that sign is going to line up with our vertical column. If you look at the sign right here that has the head, you'll see that even though the center of the sign, if we did a tight bounding box around everything, would be more towards the cheek over here, centering and normalization makes sure that the head is actually horizontally centered properly, and that way we can tell the right side from the left side very quickly. It helps with our helps with the speed that we can read at. Let's take a look at Sign Maker and take a look at exactly how this is going to go. I'll scroll down and we'll open up the US ASL dictionary. Let's put two hand shapes here, and if we center them, the center, like I said, we draw a tight bounding box around our symbols, and we calculate the mathematical center, and this mathematical center is that 500 by 500. No matter how many symbols we put in there and what arrangement, draw a tight bounding box, find the center. And that's where the center is going to be. The head shapes all have different rules. The head shapes take precedence. So if there is a head shape, it will actually ignore the other symbols and it will center it based on the head. And we can see that. We can move these hand shapes anywhere we want, and the center will always stay the same. I was talking about that bounding box. If there's multiple heads in a sign, the bounding box will be only around the head shape. So if we put those there and we center, you can see that it's that tight bounding box around the head. The position of the other symbols does not matter. It will not affect the center. But moving the head shapes, we get a new center. All right, let's go over to codesandbox.io and check it out. We'll create a sandbox, just vanilla. Sandbox, sorry. There we go. All right. First thing we want to do is we're going to add a dependency. Our dependency in this case is Sutton SignWriting font TTF. All right, that is added. Now we need to import it. Let's go back over to the documentation. And we want to use it as a module. Excellent. And we are going to import everything as TTF from the Sutton SignWriting font TTF package. And we can just paste that right in there. Control V. Okay. Now that we have it installed, the first thing we want to do is we're going to do ttf.font.css append. This is going to add some CSS rules to our page in the background as a style element, and that will make our fonts available so that we can use that. The only thing is, if somebody doesn't have the font installed, it will download it from the internet, so we need to make sure that we don't start until the CSS is loaded. So we can use the CSS loaded function. The only thing is, this does take a function itself, so we'll just use a arrow function and define the function in there. So once our CSS is loaded, it will call this function inside. All right. So it is ready. All right, we'll do a var spatials equals, we're gonna have a symbol key S10000. Then we need to give it coordinates. We'll put it at 480 by 480. Let's put another spatial symbol in there, S20500, and we'll do 520 by 520. All right. So now let's build our sign. This is going to be our unnormalized sign. So we're going to put it in the middle lane. We're just going to give it 500 by 500 as the pre-processed max coordinate. That's going to be overwritten anyway. And then we're going to, let's add the spatials. We're going to join. And we're just going to join it with no spaces in between. All right, now we have to normalize it. So let's var norm equals ttf dot, and this is in the FSW section. Let's go take a look. FSW sign normalize. We just call it and give it our sign in FSW. All right, so sign FSW dot sign normalize. We pass it the sign. Excellent. Let's do one more thing. We'll do a var svg equals ttf.fsw.sign svg, and we give it our norm. All right, we don't have anything output yet, so let's get that put in here. Let's have the, we'll put the regular sign, and then we'll add our break so we can get a new line, and then we'll add the normalized string. Let's put another break in there, and then we will add our SVG. And you can see that we have our unnormalized sign right here, and then we have our normalized sign. There's a couple interesting things to look at. First of all, this symbol key was put at this coordinate of 480 by 480, but once that was normalized, our symbol was actually at a different position. It's 475 by 475. And the same thing happened with our contact star, the S20500. Rather than be at 520 by 520, it went 515 by 515. And you'll also notice that we have a new max coordinate. This is a pre-processed max coordinate, and it tells us where our sign ends. Let me show you. Rather than, well, let's say we'll set our norm equal to sign. When we set our norm equal to sign and we try to make an SVG, you'll see that our sign is actually cut off. The minimum coordinate works out just fine. It's that max coordinate that doesn't actually show up. If we go in here and we change max coordinate to something else, you can see that more of our sign shows up. We need to keep increasing it until we actually see everything around it. To make this even more clear, when we make our sign SVG, since this can take a style string, let's give it a background of light blue. We change this back to 520. You can see that the size of our sign box is changing. If we actually use our normalized sign, you can see that it properly puts it. And no matter what we have up here in our unnormalized sign, it doesn't matter, because once we normalize it, the sign will appear properly. So that is sign normalization. It relies on the size of each of the symbols. If you look at our code, you can see that there is a FSW symbol size, and you send it a symbol string and it tells you the size. So that is sign normalization, relies on the symbol size. And once you get it normalized, it will not only be centered properly, but it'll also be sized appropriately too. I hope that was interesting and helpful. Have a good day. All right.
A lot of information, but I know people are reading it because I can see they're writing, you know, they're saying something and asking questions about the fonts. Did you know that? So later we have to read what they've said. Okay, what's next?
We have one last video to show, and this is about the SignWriting web components. So let's take a look at that.
Components. Okay, let's look at that. Right. Next.
Welcome to the SignWriting stream, where we show, teach, and demo all about Sutton SignWriting. This week's episode, a preview of the Sutton SignWriting web components. Let's get started. As always, hop on over to our open chat on Gitter. We'd love to hear your comments, questions, or help you with your project. The SGNW-components package. You can find the source code available on GitHub, and we have also posted to NPM. This is a JavaScript package for the browser that includes a collection of web components built with stenciljs.com. It's an early release for testing and development. Feedback is welcome. We're talking about web components. We have a variety of web components planned, including symbols and sign boxes and sign maker, symbol palette, paragraphs, vertical paragraphs. Right now, I got a basic example up and running for the SGNW-symbol element. You can see several examples of how to use this symbol element. We can define our values explicitly because we support FSW as formal sign writing in ASCII. We support SWU sign writing in Unicode, and we also support the IID, which is the ISWA 2010 ID. These can be explicitly set as properties, or you can implicitly define them if you make that the contents of the element themselves. The component is smart enough to figure out what kind of data we're giving it and display appropriately. Let's hop over to CodePen and paste in some code. So here are our example symbols. Now you'll see that we don't see any sign writing right now, and that's because we cannot just open up a random web page and use our SGNW-symbol element. That's because we need to first configure it. Luckily, that's really easy. All we have to do is add one script tag. And this points to our component source code available on unpackage. So let's copy that. And we can put this script tag in any HTML page, and it will automatically load our library and our fonts. And there it is. If you want to update a value, you can just set it up to whatever symbol key that you want, or you can update the IID. And that's what I have so far. Later we'll have more elements, and these elements will have more features as well. As I said, this was built with StencilJS. It's a great development framework. You can read about the docs and all about Stencil, or you can dive right into the component reference, talking about the API, decorators, and lifecycle hooks, and other things that they have. If you go take a look at the code, you'll see that we have a source directory, and then inside the source directory, we have a components directory, and this lists all the components that we have up and running. Like I said, this is an early release. Details are bound to change on the inside of the symbols, and it's going to be a lot of fun to start building these out. So go ahead and try it out. Check back with the repo and see how things are going. And I can't wait to see what you can build with these SignWriting components. Thanks. Wow, that was a really early release.
Oh, we were not seeing that for a long time. It was an early distribution, right? So now, have you changed it a lot? In
Well,
recent,
let's go take a look.
look, he doesn't remember exactly what he's been posting. There's so many years, yeah.
All right, so here we have the SignWriting web components on GitHub. There we go. We have significantly more downloads. We have 1.7 thousand downloads. And we're going to go down here to the documentation. Now, for the documentation, we have SGNW components that use the SignWriting in Unicode, SWU, and we also have FSW components, which uses formal SignWriting in ASCII. So far, we have symbols, signs, vertical paragraphs, buttons. We have the palette symbol and the palette. The sign box is a work in progress. I need to post a new update, but it's coming along. Eventually, we will have all of the components that we need in order to be able to build SignMaker. Let's take a look at the FSW VP. If we take a look at the SWVP, we can see that here is our vertical paragraph, where it has all of our writing and it has it in a nice vertical paragraph. You can see we can supports it reads the CSS from the web page that it is on, so it can accommodate to the color that you have for your text. And to make that vertical paragraph, all we had to do is say vertical paragraph equals, and we give it our formal SignWriting string right there. And it accepts colorized flag. So let's go back here for a second. I'm going to go to the additional examples. And we can see here, I set the height, the font size, and the color just by giving it that style. So we tell it what we want. Down here, we said, hey, we want it colorized. So we actually passed colorize for our vertical paragraph. Like I said, there's also additional signs. So if you want a FSW sign, you just say FSW sign and you give it the sign right there. Right here, this is actually a sign link. So because it's as an anchor and we give it the href, so it knows to colorize it properly. Then we can also just set the style by saying, hey, the color is red and the background is yellow. And you can also use the styling string. The FSW palette is actually complete. And this is a fully functional symbol palette. And if you want to get it, all you need to do is say FSW palette, orientation horizontal, small. And you can click through, and these are fully draggable and droppable. And when they drop, they will fire events that you can capture. If I go over here to the additional examples for the FSW palette, you can see here's horizontal, here's our horizontal medium size, and here's our horizontal large. Because if you notice here, I'll click on the index hand shape. It shows half of the symbols, and you need to go down the bottom to get the other side. Where when I make the size large, when I click on a hand shape and click on a symbol, I get all the symbols that I could possibly want to use. You can not only make a horizontal, you can also make a vertical symbol palette. And again, you can do all the different sizes that you want. Again, these are drag and droppable. Drag them over, you drop it, fires off an event that you can capture. Like I said, I'm still working on the symbol palette. Sorry, the sign box. And once I have the sign box and get some extra commands in there, we'll actually be able to build a sign maker right inside of any web page using these SignWriting web components. That was the FSW reference. We also have SGNW, and this uses the SignWriting and Unicode web component. So you can just say, hey, I want to see a symbol. Here's the symbol that I want to do. Let's take a look at the sign. So I say, give me a sign. Here's the sign, and it automatically puts the sign for me. Here I put it inside of a link. I say an H with an H, or an A with an href. And inside I say the sign, and it knows to properly color it. I can also, like I said, give it a size, give it a color, give it a background. It also works with the style string. So that is the SignWriting web components and where they stand right now. And they are continuing to get better. And people are actually starting to build with the SignWriting web components and the other SignWriting packages. And it's a very exciting time.
It's an exciting time, yes. Thank you. And I can see other people are thanking you online right now also.
Oh, that's very nice.
We realize, Steve, that without all of your work on the World Wide Web, we would not have what we have right now. You know, we started with, you know, computers sitting on a table in a house without any connection with internet, right? Like the SignWriter DOS program by Rich Cleaves. But when we moved into the World Wide Web, it's a different world. And you helped us move into that world. And we thank you very much. It's a beautiful presentation. And I don't know if people realize, but a lot of what was shown today was already posted on our signwriting.org page, isn't that right? Where we've been streaming your work. So we're going to put more. And what more do you want to say?
Well, let me share a couple more closing slides.
Okay, I'm sorry, I didn't realize.
Not at all.
Just a
All
lot.
right, so if you would like to know more, just head on over to sutton-signwriting.io. I list all the software available. If you want to read the technical specification, you can look at Draft Slavinsky Formal Signwriting. It's a very dense material, but it covers everything about formal signwriting in detail. If you'd like to know more about me, you go ahead and hop over to steveslavinsky.me. You can feel free to send me an email at any time, slavinsky@signwriting.org, or hop on over to the online chat where we have the signwriting community on Gitter. Every Saturday morning, I have office hours. I'm also working Sunday on signwriting. It's just such a blessing to be able to keep working on signwriting, and I'm going to be around here for many years to come. If you'd like to support our work, use SignWriting and enjoy. SignWriting is free to use for personal or commercial use. Anything that you want to do with SignWriting, we would love to help you do. If you want to discuss and build on our work, that is the highest praise that we could possibly receive. It is so gratifying to see such great work being done, to watch literature being written, to see education being transformed. I am just in awe of everything that everybody has done, and it is really our great pleasure to be able to help and support you in that. If you'd like to consider financially supporting our work, that would be much appreciated. You can head on over to our Patreon. We have a Patreon for signwriting. It helps support, we have the SignWriting flagship server that's running signwriting.org. We have the SignWriting legacy server that's supporting SignBank and SignPuddle 2. There's software that we need to purchase, licenses and services, even equipment. And anything that you can do would be greatly appreciated. If you're unable to, that's fine. Use SignWriting and enjoy, because that really is the most important thing for us to do. But if you know somebody that could possibly help us, send them a link. Ask them, hey, why not?
I agree. I just want to inform everyone that Steve is donating his time. Do you realize that? How wonderful. He set up this whole Symposium with Hobins from Brazil and Adam and me, but it was really Steve's idea to do it again, right? Before we finished, I guess it was 2017, 2018, I guess, 2018. And then we stopped, so it was 5 years. And now, because of Steve and his donation of time, we have this SignWriting Symposium. So thank you. And remember, he just said the patreon.com/SignWriting, right? That's his World Web page. And I know I'm going to go donate, and I just hope that you all will help support Steve. You know, many years ago, I started a non-profit, I guess, or a non-profit. I don't know how to sign that really, but we had one, and it was called the Center for Sutton Movement Writing. And at that time, Steve and other people like Adam, they worked with us under that organization. And how did that work? Here in the US, we would collect funds through the government permission. It was like a legal thing. We could ask for donations, and then the people who gave would get a tax benefit, I guess. That was how our non-profit organizations worked here in the US at that time. And then it was like 46 years, I think. I think we controlled that, but I just couldn't continue, and I had to retire. And so in 2020, when COVID started, we closed the Center for Sutton Movement Writing. And I thought to myself, oh, I just hope that SignWriting continues. And I didn't know if Steve or other people would want to continue, because they had to go and get other jobs. And Steve went and got another job with the University of Iowa. You're a tech support person, right? Doing other things, having no connection with SignWriting, and it's a full-time job, and it's a hard job. And then found out that he wanted to donate his time on the weekends. I was so surprised and so appreciative. Really, thank you so much. So that's why it's necessary to get the Patreon donations from all of you to help Steve continue. And we want to thank you for thinking about that. I'm going to pray that maybe the wonderful world that we live in with the internet, there's so many good people like all of you, that we can work together to make SignWriting spread. And I want to thank you, Steve, for making that possible. And thank you for all of the presentations that makes it possible. Also, everyone was wonderful. It really was. And you even tried to look at my signing. That was very nice. So, anything more, Steve, that you want to say?
I just want to thank all the presenters that took their time and energy to make these wonderful presentations, not to mention all the work that they go into learning and using and spreading SignWriting. We're really blessed and really humbled, and just thank you.
Grateful, yeah. Yes, we're blessed, and we really want to continue to know all of you, and we hope that we'll continue to be in contact. And I'm really looking forward to putting all of your papers and videos on different World Wide Web pages. It's going to be a lot of fun, and then I can contact each one of you privately, and you can tell me what you want, and we'll design it together. Okay. Okay, so thank you again for 4 days of the SignWriting Symposium. Mwah. Love from us.